Namaskar, sir.
Namaskar. Can you hear me?
Yeah, we can hear you, sir. Just 1 minute, sir. We will come here.
No problem. Take your time.
Yes, sir.
Anjan.
नहीं मैं बोल रही ठीक इधर आ जाओ ना इधर आ जाओ इधर आ जाओ ना ठीक है आप बैठे दोस्तों बैठ
Namaskar. A very good afternoon to everyone. I, Manisha, on behalf of CSIR-IIP OWOL Alumni Meet Organizing Committee, feel privileged to welcome you all. As we all know, that CSIR has started a 1 week, 1 lakh campaign for showcasing the capabilities, achievements, innovation, activity, and contributions by each CSIR lab. In line with this, we at CSIR-IIP is organizing this event from 13th to 19th April 2023. As part of this program, we had the inaugural and stakeholders meet on 13th April at New Delhi, followed by a celebration of our Founders Day on 14th April. And we have also planned several other activities such as Nature's Walk, Gram Chopal, Industry Meet, and MSME and CSR Collaboration Meet, showcasing our collaboration with our partners and stakeholders. Today, we are planning for an alumni meet. It is a pleasure to see you all here in the alumni meet. I feel highly grateful to welcome you all back in this abode of education where you spend some part of your life. The alumni meet will consist of technical presentation, panel discussion, followed by open forum for our alumni to share their memories and association with CSIR-IIP. Before starting the event, I would like to request our director, Dr. Anjan Ray, to welcome our former director, Mr. Sudhir Singhal by presenting him a sapling and an Angavastra.
Thank you, Minister. It relates to the gifting of plants to Mr. Singhal because it is through his efforts and inspiration that there are thousands of plants not only in IIP but across Dehradun. Right? So this is on right look here.
I would like to request Director CSIR-IIP Dr. Anjan Ray, formally welcome Director Technical CTCL P. U. Venkataram by presenting him a sapling and a Angavastra.
Last week when I purchased. No. Extra.
Like to request Director CSIR-IIP Dr. Anjan Ray to welcome Shri K.K. Jain, former ED, PhD, by presenting him a sapling and an Angavastra.
So this is the highest technology the world can have. Internet technology.
To start with, we would like to have opening remarks from former director Dr. Ram Vishwakarma ji. Before I invite him for his welcome address, I would like to give a brief introduction of Dr. Ram Vishwakarma ji. Dr. Ram Vishwakarma was former director of CSIR-IIP and former director of CSIR Indian Institute of Integrative Medicine, Jammu. Prior to joining IIM, he worked as vice president, Pyramid Life Sciences, Mumbai, on NCE discovery on cancer, inflammation, and drug-resistant infections. Prior to that, he did his PhD from CDRI Lucknow and postdoctoral work from University of Cambridge on biosynthesis of vitamin B12. He has expertise in new drug discovery, medicinal chemistry, organic synthesis, chemical biology, and glycobiology, and has over 200 publications and 35 patents to his credit. He is an elected fellow of National Academy of Sciences and was awarded Sun Pharma Research Award in Pharmaceutical Sciences in year 2014. So I request you for your opening remarks, please.
Thank you. Can you hear me?
Yes.
Yeah. So I will begin by thanking Dr. Anjan Ray, Dr. Jain, Dr. Gupta, and all my colleagues at Indian Institute of Petroleum to give me this opportunity to be part of all of you. I was all set to come physically, but because of these numbers going up of the virus, and particularly Anjan knows my virus friendliness, so I was advised to take care. And hopefully very soon I will come alone so that, I can be there for at least 1 day or 2 days because I have a special affinity for this institute. As far as this 1 week, 1 lab program is concerned, also I would like to welcome you all in my different capacity because I am the chair of this PEN CSIR organizing committee, which organizes this 1 week, 1 lab program across the CSIR. Also, my special privilege to be in the company of Dr. Sudhir Singhal. Hopefully, I should be able to meet him one day. And of course, Dr. Venkatramanan, and Dr. Chen. I was hoping that I will see Dr. Garg, but maybe I'll see him sometime in Bombay. This important need, whosoever conceptualize this, is a very interesting idea to hear from people who have the I exclude myself. I don't have that deep memory of this institute, but there are people who have built this institution, worked in it, and also have that trajectory. Because if you understand your trajectory well, you can plan it well. So I think this is a very thoughtful. Anjan, you thought about this event. This will give a lot of input and encouragement for people, those who work in this very interesting and very premier institute of our country. And the subject also is very close to my heart. I had several discussions with Anjan almost for last 6 years. And before that, Dr. Garg, the challenges and opportunities in oil and gas industry. And of course, future-oriented direction to achieve clean and sustainable energy. Among all the sectors of human activity, all of you know, this is one sector which is going rapid, dramatic, like clear and present, as they say, changes. So there is onus on scientific community because it rarely happens in a particular sector when things are changing so rapidly. Because as we know, by the nature of science, we can't change our direction so quickly. It takes years to learn something, then translate it, then harness it. It's the nature of beast. But things are changing pretty rapidly. As I see as a outsider broadly. So it's a great opportunity and challenge for scientific community, engineering community, as well as industry to really think about what changes are in place. Yesterday, in fact, we had a very interesting discussion which was chaired by Oxford University Vice Chancellor, where they were reimagining future of pharma innovation. So compared to that, reimagining, I think this reimagining is much immediate. And I think when the whole world is reimagining this sort of non-renewable precious source of humanity, it's incumbent on Indian Institute of Petroleum also to reimagine itself and reposition itself to challenges and opportunities that are going to come. I think it is unavoidable that we have to sort of, and when I was there for a few months, I was so happy, and I always expressed it, that the quality of infrastructure, quality of talent, which is unassuming, not so making noises like people make, but solid work. And this institution is one institution which actually has laid down the knowledge foundation of our petroleum industry in the country. Maybe new institutions have come up with maybe more resource, more human resources and physical resources. But I think like many other CSR institutions, this is one of the pioneering institutions which helped continue from the very beginning to grow this very large industry in India. And I think imprint of this institution will be everywhere, wherever sector you go, whether the oil sector. I remember 25 years ago, one of my, I will not say colleague, senior, but we shared the same postdoctoral professor. He was head of R&D of IOC in Faridabad or Gurgaon, wherever it is, Dr. Bhatnagar. And that time I used to meet him and he used to talk about this institution, but how they were trying to set up the R&D at that time. So I think this is the great lineage, great leadership. Dr. Singhal is sitting here and those who have built this institution with solid foundation. And second time I witnessed the power of this institution, which was awesome during the first, I think, 2 years since the pandemic. And Anjan knows that, every day from 6 p.m. to 9 p.m., 8 directors and director general of CSR used to sit together every day, and we used to plan what we should do for this emergency that country is facing. And I tell you, I must take this opportunity to really compliment and congratulate Indian Institute of Petroleum, the kind of contribution they made during that time. Anjan Ray made contribution across the sector as a leader in that group, but scientists at the Dehradun, they did remarkable contribution. Many of you may not be able to appreciate actually what you did. 3 days ago, I was talking to a team from MP Council of Science and Technology Engine. Their DG had some meeting in DBT, and suddenly he's talking about COVID, and then he started about oxygen support, cylinder technology from IIP, and he was all like how many lives we saved there. And I think when you hear this, even one life saved is it's enormous. How many people get opportunity to really do that? And so I think this is phenomenal contribution that was made 3-4 areas and laboratories which were not actually meant for that purpose. That was done so remarkably well. So I think all heads up to you. I think it's a phenomenal work, and I think that should give you confidence to move forward. And the whole idea of this celebrating this 1 week is that to identify those challenges. To me, challenges for this particular resource is very briefly, and I've articulated earlier also with my colleague at IIP, and some thought process has started, but I think this should be rapidly taken up. Is that we have to prepare ourselves because this is a fundamental science institution also. It's a technology provider on one hand, but also had an onus. This is the only institution in the country which has responsibility to keep pace with the fundamental science that is required for repositioning this. This is important. I'm making distinction. You may have refineries, you may have all these public funded organizations, but that soul of all these things happen in the industry sector is ultimately remain fundamental science, which is transformational science in terms of the taking industry forward. So I think that is where I see that maybe it will be blessing in disguise when these changes are appearing, that we will then, instead of high volume to low value product sector, I always say that, don't mind me, what am I saying this, but why I'm saying this, that we take this very large volume resource from earth, which is the non-renewable, and we convert them into fuel, which is essentially is basically used up in different forms and creating economic activity others. So I think this will be an opportunity for really reduce the volume that we use, but create high value products and high value technology. I think we have to reimagine maybe 150 years ago what happened in Germany when petroleum industry led to birth of pharmaceutical industry. I don't know how many young people know in this audience. I can tell you with all my knowledge, the pharmaceutical industry started with petroleum industry. And welcome, Dr. Garg. I was just taking your name. Good to see you.
I thought you would come here and we'll have a chance to meet you.
I was telling Anjan that I was all set to come, but because of number of coronavirus cases going up here in Gurgaon and Delhi, I was advised that don't take risk, because these numbers are deceptive, because although they are 5,000, 10,000, but number of people getting tested is so low, that number can be easily multiplied by tenfold in our situation. And his situation is bad because yesterday I had a discussion with Dr. Naresh Trehan of Medanta, happened to be in some discussion, and he said, doctors are getting down now. So that's a warning signal. When doctors started getting coronavirus, then you start getting worried because people are also. So I think I will also request all of you to please start taking care, because this suddenly will boom, and hopefully, and also it's going up across the world as well. So anyway, I'm coming to, I'm very happy now Dr. Garg is also here. So I think special privilege to see him in the audience. And Dr. Garg, I was just saying, because they considered me as their alumnus, so I took this opportunity to say a few things. So I was just saying same thing, that IIP has a great responsibility as only one institution dedicated to create new knowledge. I'm saying that very, very responsibly, new knowledge in this particular sector. There may be refineries, there may be great institutions, there may be other public sector companies, but this is one institution where the onus of creating new knowledge to reposition the country and new position sector in a new changing scenario. I can just quote because data is very different. I know Arab countries, G5 countries, they call them G5 countries, have recently made a declaration that they have to move away 40% of their oil GDP to non-oil GDP area in next 20 years. So you can imagine these kind of global changes that are happening, and that is where I think science will drive this particular resource to a more value-added industry and more value-added product. And I was just giving example of that. Perhaps we have to go back to sometimes cyclical things that, like pharmaceutical industry started in Germany with petroleum industry. Almost literally started from there. And I think we have to look back again to pharmaceutical industry to provide KSMs and all kinds of materials and technology to that particular several sectors, aroma sector we talked about, nutrition sector, like what is happening in now Japan. They started microalgae for diesel and petrol, but actually repositioning for whole nutraceutical sector is booming. Energy requirement. In fact, people have started talking about that maybe in 50 years' time, the half of the humanity's food will come from sea sources where these organisms will play a very important role. So I think this is my request and my suggestion is that brainstormings in these areas should start and IIP should take lead so that the government is kept well informed, because government on its own doesn't have its own sort of bandwidth to understand these areas. We scientists, we can foresee things much better, much earlier. So I think that is important that we take that initiative. And I think this is one good initiative, very thoughtful. I think what I said captures this particular. So I look forward to listening from you and learning. And again, I thank you all for providing this opportunity. I will be there in the meeting and listening to all my colleagues. Thank you very much.
For setting the tone for today's deliberation, and thank you very much for your kind suggestions and appreciation. Thank you for joining us, sir. So before I would like to request Director CSIR-IIP, Dr. Anjan Ray, to present a memento and to present the Bangavastra and plant sapling to Dr. M. Garg, former Director CSIR-IIP, former DG and President RIP. So, moving ahead to conduct the technical presentation followed by panel discussion, I would like to invite Sudhi Singhal, former Director, CSIR-IIP, conduct both the session. Would like to give a brief about Mr. Sudhi Singhal. Mr. Sudhi Singhal holds a BTech honors in mechanical engineering from IIT Kharagpur in 1965 and MS in tribology from UK in 1969. He joined CSIR-IIP in 1965 as scientist and rose to become director of CSIR-IIP, from where he was elected in 2003. His major research interests are application of fuels and lubricants in IC engines and in industrial machinery, energy and alternative fuels, including alcohols, CNG, biodiesel, SVO, etc., lubrication and tribology. He has more than 250 research papers to his credit and contributed more than 250 technical reports for industry on sponsored research. Has represented India at several international forums and has been a member of very large number of national and international committees. He received the Technologist of the Year award in 2002. He is also the first recipient of Uttaranchal Ratan Award in 2003. Now I request Dr. Sudhi Singhal to kindly conduct the proceeding for presentations as well as the panel discussion. Over to you, sir.
Thank you, Manisha. Thank you.
Thank you, sir.
Do I keep sitting here or what?
Yes, if you would prefer to stand and talk, that's also
I
fine.
will. I've got to go back.
Mr. Venkatraman, Mr. Jain, Dr. Ray, Dr. Garg, and all the other friends. Good afternoon to you all. For me, this is a very nostalgic moment, coming back to IIP and meeting all of you and sitting in this room here. I have too many thoughts. I don't think I can convey all of them to you. I'll try to convey some of them which are occurring to me at this point of time. When I first came to IIP, this hall was not there. This building was not there. It was a Saturday afternoon. In those days, IIP used to work for 5.5 days in a week. Since this is a foundation day also, and IIP's journey has been 60 years, I believe I have the liberty to say a few things of this kind also. I had just come fresh from IIT Kharagpur. I did not have my degree in my hand. My degree had not come by that time. Why I came here, I do not know. Before I went out of the IIP campus, the director used to sit on what is now the tech block. He was the only person who was in the campus at that time. And I happened to meet him. I went back from IIP with a job in my hand. I didn't even have a degree at that time. So that's a long story. I will not go into the details of that. Dr. Vishwakarma has triggered a lot of thoughts in my mind today also. I'll touch upon them in a moment or two. But looking at the history of petroleum related developments, particularly downstream in India, I think I can very proudly say that the IIP has been one of the biggest contributors for that to have happened. Most of you are quite young. You may, maybe he remembers a little bit, but you may or may not know. In 1957, by an act of parliament, India reduced the price of crude oil which India used to import from $1.59 to $1.57. India had contracted a million-ton consignment of crude oil without knowing how to. So the point of telling you that is, we did not even know in 1950, in those days, how to handle what of petroleum. Our beginnings have been like that. We used to have the Burma Shell Oil Storage and Distribution Company Limited. The name some of you might have known. So the petroleum used to come from outside, and the Burma Shell used to sell it in the outlets in the country. So in the early 60s, that was our status of knowledge of petroleum. Another very small incident. 1962, the war we had with China. We had our forces in the northern belt. China attacked us, and all the soldiers were standing there. Not one single Indian gun could fire because the lubricants in all the guns had frozen solid at that altitude and at those temperatures. Indian Army had not heard of the term called viscosity or anything of that kind. So these are the beginnings this country has had in terms of knowledge of petroleum. At that time, 1963, IIP came up, and from that on, I don't have to say anything. You all know what happened after that. Since today's session is on a few things, not just one, I'll mention one or two more things in that context. In the 70s, even in the 80s, our diesel fuel had 1% sulfur. Today, you will be aghast at this number. We are talking 10 ppm or below. And the government at the time, in their wisdom, had decided not to put any duty on diesel, only on gasoline, with the result that for about 30 years or 35 years, the price of gasoline used to be 3 times that of the diesel fuel. I mean, those of you who are slightly older, you will know that the petrol was 15 rupees a liter and diesel was 5 rupees a liter. Both prices. This was the promotion for a very long time, till late 90s. It happened in late 90s. The ratio began to change for some other reasons. The result of that was, because diesel was cheaper and because the diesel engine has a slightly higher thermal efficiency than gasoline, India was the only country in the world where all commercial vehicles used to run on diesel, all railway engines used to run on diesel, all farm equipment runs on diesel, and anything industry used to run on diesel, and petrol could not be used because it was very, very expensive at that time. Now, this put a very high demand on the demand for diesel in the Indian refineries. Now, for a barrel of crude oil, you can produce so much diesel. We wanted so much. So all kinds of things happened. We had 1% sulfur in the diesel fuel. We used to have many other kinds of things also happen, and so on. We had very few cars also at that time for that reason also. But then things began to change slowly. More cars came and the industry grew and many more things began to happen. So one day the country felt that, look, I mean, we have all these problems, and I'm not going to define these types of problems today, because all the refinery had to do to manufacture the higher quantities of diesel. In fact, our refineries were not optimizing diesel production, our refineries were maximizing diesel production. Dr. Garg would know too well about that. And then we have things like 1% sulfur and very wide range of distillation diesel fuels, which were bad for the engines and so on. So our emissions were more. Then suddenly we wanted to improve our fuels, we wanted to improve our engines, we wanted to improve our environment, our air. How does one go about that? It was not an easy thing to do. If you want good air quality, you need better quality engines which emit less. If you want better quality technology in engines, you need better quality fuels. They can provide that food to the engine, and it was a vicious circle. One of the biggest milestones, or if is a better milestone, maybe a tower or a Qutub Minar, we had the Auto Fuel Policy Committee come up in the late 90s. I am one of the signatories of the Auto Fuel Policy Report. For the first time in the country, we laid down what should be our emission norms and the corresponding fuel quality. When that began to happen, we had a very interesting reaction from the industry, both from the petroleum industry as well as the automotive industry. I don't know whether I'm talking too much, Dr. Ray.
No, it's a fascinating.
For 2 or 3 minutes more.
No, please. It's a historical perspective that is fascinating for many of us. So
you first talk to the petroleum industry that, look, we don't want 1% sulfur fuel. We want 100 ppm or 0.1 or 10, 50 ppm at that time. The immediate answer from the petroleum industry, and I have one witness sitting here, this cannot be done. This cannot be done.
It's commercially unviable.
No, I'm coming to that.
used to rush to me.
Then you press them a little more, they'll say, okay, technically this can be done, it's too expensive, the country cannot afford it.
Yes.
And the next thing that was happening was the country was producing it, all that was happening, and we had those fuels. The same thing happened with the automotive industry. To talk of, at that time, Euro 1 or Euro 2 norms, the automotive industry said, no, this cannot be done. The Indian industry in India, nobody will buy vehicles if that happened.
It will take 10 years.
Again, then they had
Vehicles will be expensive.
Again, the same thing. If you do it, it will be too expensive, and from where you will get technology, nobody will get this technology. In this kind of a climate, the Auto Fuel Policy Committee came, And I think it laid down a very, very sound base in the country for fuel quality development and emission norms. I don't have to repeat that. You all know much more on that today than I do. Since it is our foundation day, and I'm quite old compared to you people at least. There's a lot of history involved here. I'll tell you one more little incident of those days. When our engines were improving, earlier we had Lambretta scooters and Vespa scooters and nothing else. Then one day all the Japanese brands came into India. And what was happening at that time, if you buy a scooter, you were used to put oil in the fuel, not like today's technology. And 6 or 7 brands that we had in the country, what they were doing, that oil that has to mix with the fuel, every time you get fuel, you used to carry your bottle in your pocket and you used to put it there.
2-stroke engines.
Two-stroke engines. The engine manufacturers said, no, you have to use our lubricant only and not anything else. And that lubricant came from Japan. All these bottles used to came from Japan. You can imagine the cost involved and the logistics involved and so on. There was a lot of discussion in the Indian petroleum industry, hum kya kare? This is too much. So one day it happened, I think in the mid-80s or so, I don't exactly remember when, from the 3 oil companies, Bharat Petroleum, Indian Oil and HPCL and IBP at that time. And the director of CHT, if I am not too mistaken, could be Mr. Narang.
Yeah.
Could Mr. Narang.
Which year are you talking about?
Mid-80s, something, early 80s maybe, so sometime then. Anyway, the director CHT, I think it was Mr. Narang. In those days, we in IIP were working very strongly on lubricants. So they came and asked, I still remember we had a small meeting in the Engines Laboratory conference room. Just 4 people from the oil industry, Mr. Narang, and 1 and 2 or 3 of my colleagues. That's all. Hum kya kare? The answer which IIP gave to them was, you completely forget Japanese 2-stroke oils. You do not need them. Whatever oils are required in the country, this country can develop them and supply them. You do not even need that technology from them. You do not even need that know-how from them. And from that day onwards, many things happened, of course. And all the Japanese oils disappeared in a period of 6 months. I don't know if you ever drove a scooter, Mr. Venkatramana. Did you ever drive a scooter?
Yes,
I have my scooter. Oh, no, you are young.
No, I'll say
You are young.
even in 1991, even in 1991, I had a kinetic spark.
Okay.
But we used to get, they would tell you, imported oil or local oil. They would tell you in the answer chahiye.
So I'm saying that, look, this is the kind of role which IIP played in the development of the petroleum industry in this country. And enough cannot be said about that.
Yeah.
One other very interesting incident happened a little later, when we were little wiser, a little more educated in the country as a whole. The problem of lead in gasoline was a big one. The whole world had done away with lead. India had not. And we used to get representatives from all these cocktail and ethyl and all these companies in our additive companies in India, trying to justify why India should not do away with lead. How it is good for India? Okay, it's not good for the rest of the world, but it's good for India.
Economically.
So one day I asked one of them a question, look, you say this like this, I mean, look, you are more learned than what we all are, you know much more about it, we know hardly anything about it. But suppose tomorrow there's a problem, will you accept liability for that? They all went away and they never came back. But the discussion in the country went on. The automotive industry as well as the petroleum industry both joined hands. Both were not in favor of doing away with lead. Petroleum industry for obvious reasons. You can't meet the octane requirements. And the automotive industry for reasons because the price of petrol will go up and that industry did not want that. So in my lifetime in IIP, I have seen enough times when they will both fight with each other.
fighting.
And on some occasions, they will join hands together and fight with us.
That fight still continues in PCD3.
And fight with us.
And they sit on both either side of the table. That is most funny.
So at that time,
Correct?
some committees were set up, and most of you were in most of the committees, I'm sure. And there must have been, I'm not exaggerating, believe me, over a period of 3 or 4 years, maybe 200 meetings. Maybe 200 meetings on to the lead or no lead, lead or no lead, and it went on like this for a long time. Now, one day, we got an invite for a meeting in the Ministry of Environment. Kamal Nath was the environment minister then. All the chairmen of all the oil companies, all the chairmen of all the automotive companies, and some people like IIP were invited. If you have attended a meeting in the Ministry of Environment, there is a very long rectangular table. Ministry Environment. So before the minister came, all the participants had to be there. They all came. And as would happen, all the petroleum people sat on one side. All the automotive people sat on one side. Long table. Then I came, I saw all the petroleum people sitting there, automotive people sitting there. Where do I sit? So I went to sit at the end. Alone. There was nobody on my side. So then somebody asked me, Singhal, why didn't you come and sit here? I said, look, I'm near the petroleum, I am near the automotive. How can I join you? Anyway, that was a joke. Then the minister came and sat down. This meeting lasted 30 seconds.
Only.
This meeting lasted 30 seconds. Kamal Nath said, look, I had a friend from USA last week. And he told me that, look, Kamal Nath, walking in the Delhi roads, like smoking 10 cigarettes in a day. And we have this lead problem. So today I am deciding, from this day, we will have no lead in gasoline in the country. Gentlemen, thank you. The meeting is finished. Gentlemen, thank you. The meeting is finished. So from that day on,
I didn't know this.
so this is how the decision was taken. Nobody was asked to speak. Nobody asked for their views. Nobody asked for any comments. That's the government of India decision.
And which year, sir?
It happened maybe late 90s. I can't exactly.
92.
No,
Early 90s.
I think 92, 93.
Could be early 90s.
When was Kamal Nath the environment minister? I wouldn't remember exactly, but
Kamal Nath, when he was in
Manmohan installation, reformers and all that.
everywhere reformers came that time.
Because of that.
First Manmohan Singh cabinet, no? So,
I don't know much of politics.
Manmohan Singh was finance minister, sorry.
Completely unless.
Narasimha Rao.
95, 96.
Narasimha Rao cabinet, no, 95.
96.
92 I operated reformer. So reformer came before that.
Yeah.
So this is the shortest meeting I ever attended in my life, and one of the most important decisions that was ever taken by the government of India. So, gentlemen, I think my stories will not end. I have to stop somewhere.
I think you have to tell a very important story, sir,
Yes, sir. Tell me that.
about the role IIP played in bringing CNG into this country. And you played a stellar role in that. I don't think anybody in the industry knows
You must.
that अगर IIP नहीं होता तो CNG नहीं आता.
अच्छा, हम आपको जो गैसअप करें वो तो सब नहीं बताएंगे. हम आपको उससे रिलेटेड उसी से रिलेटेड एक पॉइंट और बताते हैं which surely younger people will not know. Anjan also will not know, and maybe you will also know.
You are all saying.
We did what Dr. Garg is saying. We had done some work on natural gas before that. Getting natural gas to our laboratories was a big task.
Yeah.
I used to get those caskets or trucks of caskets in trucks and so on. It was a very difficult task at that time. And then we had converted some engines in the DTC and some other places. And there are some component manufacturing companies which are manufacturing these kits for retrofitting CNG kits in our existing trucks and buses. At that time, there were two of them. I forget their names now. And by that time, some little standards had been laid down also. And we did the testing in our engines laboratory, and in IIP, and the first kit we rejected. Then we tested the second kit. We rejected the second kit also. So not me. So the villain in the country was Sudhir Singhal at that time.
There you go.
Sudhir Singhal was villain for many other things also, but that's besides the point.
There was a Supreme Court order.
There were Supreme Court committees, and I was on the Supreme Court committee also. Now, interesting thing happened after that. The first company filed a criminal complaint in some court in Delhi that Mr. Sudhir Singhal and his friends in IIP have shown favors to the other company. And the second company also filed a criminal complaint that favors have been shown by Mr. Sudhir Singhal and his colleagues to the other company.
Right.
And one day, a policeman came to my office. This was when I was the acting director, so I think 89 or 90. I presume not to arrest me, but to come and talk to me. He didn't very clearly mention what he has come for, but maybe he came to arrest me also, I don't know. So anyway, somehow you could get rid of him. And I rushed to my friend Gurelal. Does anybody know the name of Gurelal?
Yes. Famous committee.
Very famous. Gurelal was the Supreme Court appointed committee chairman.
Yes.
And
Environmental Protection Committee.
Environmental Protection Committee. I forget the names now, sorry. I left IIP 20 years back. So I went straight to him. Sir, this is what has happened. What do I do? They have come to arrest me. Chances are they will first arrest me and then we will fight the cases in the court somewhere. CSIR also was, I thought about it. I thought CSIR also may not come to my rescue in the proper way. So I went to Gurelal. Gurelal sat down. Just single but Joe. So he has thought for half a minute or 1 minute. ठीक है तुम जाओ कुछ नहीं होगा. तुम जाओ कुछ नहीं होगा. So this is the CNG story. I can't tell you the whole story. It's too long.
Yeah.
And there are enough reports in IIP of the Engines laboratory on CNG convergence and testing and this and that. So that
Look, what is today a commercial success started with those testing of kits at IIT.
I mean that also reminds me of another thing. I just say one or two sentences only on that. On methanol assisted diesel bus convergence, on CNG convergence, on ethanol, and so on and so forth. In that period of the late 80s or early 90s, we had done about 7 to 8 million kilometers of road trials on commercial vehicles. 7 to 8 million kilometers of road trials.
Our car used to be here. Green car.
Okay.
That was on biodiesel.
It was an
The biodiesel came a little later. Before that,
2003, I think.
so 7 to 8 million kilometers of trials is not a joke. We had put in a very, very large effort in the country at that time. So anyway, in short, I have had the most interesting time of my life in IIP. And some thoughts from Dr. Vishwakarma today on the future of the petroleum industry and future of the pharmaceutical industry has triggered some thoughts in my mind today. And my story, as I said, will not end, but I have to stop completely. So the proceedings can go on. With these few words, I thank IIP for inviting me here and meeting all the old colleagues.
Thank you, sir. You have to conduct the proceedings.
Yes, I'm coming to that. Now, as our luck would have it, we have some outstanding speakers for this session today. In Mr. Venkatraman, Dr. Garg, and Mr. Jain. And I'll request Manisha perhaps to start the session on these. The topics of the presentations are each a little different from each other. So I will not make any common remarks about that.
Yeah.
After they make the presentations, I will perhaps like to do that.
So you have to introduce some speakers.
5 students also.
Yeah.
You can keep the intros very brief.
Okay.
I'll make it very simple for you.
Yeah.
If you all agree with me, please raise your hand. Dr. Garg needs no introduction.
No doubt.
Mr. Venkatraman is a very old friend. We have been meeting on umpteen platforms in the petroleum industry.
He's also an alumni of IIP.
All everybody.
The DET training program.
Everyone here is an alumni. Yes, yes.
He was reminding me that he has attended my lectures in IIP. I didn't know that.
And out of here,
I didn't know that.
Which year?
83.
83, all right.
You shared the certificate which received in 82.
All right.
83. Because at that time we used to take your evaluation, give you the grading.
That time 2 exams were there. My exams second grading. Out of 70, I think. Out of 70, only 30 is
Higher than that?
Make it CBT, multiple choice.
out of 70, 13 were given A grade. Only
It was
30.
a 1 year course, right? Or 6?
No.
You know, 3
Short course. In 83, you are not running long.
In the beginning, it was 1 year.
It used to be 3 months course.
Did I give a 1 day lecture on solvent extraction in that?
Yes.
I do that for your batch?
No, I didn't do.
Maybe a year after.
Maybe Mohanlal.
Mohan.
He
That was on
gave for solvent extraction. I remember all the faculty subs. Most of the faculty side.
So I suggest let's have the first presentation of Mr. Venkatraman.
Okay.
Mr. Venkatraman is a chemical engineer from IIT Kharagpur. My co-alumni,
Yes, sir.
my co-alumni,
Great.
Nehru Hall.
and 31 years experience in operations, technical services, benchmarking, crude oil sections, projects at Baroni, Gujarat, Mathura, refineries, YOCL, and his head office in New Delhi. Between 2.5 years at the NNPC Port Harcourt refinery in Nigeria. With this kind of experience, we should not waste any more time. And this.
He was director technical of CPC.
Yeah.
Yes.
That's where I met you last.
Yes, sir.
If you want, we can keep it here as well.
Okay.
Yeah.
I have to stand before big people. They will, please.
How much time does it have?
Half an hour.
20 minutes? No, 20 minutes. Just minutes.
Okay. Okay, let me. Good afternoon, everybody. Thank you for the opportunity given to me. These slides, basically, I used to present it to. I presented this type of topics earlier also, but I have to change the whole contents because the scenario of the global scenario has changed. The challenges have become different totally. Previously, the challenges were for refineries were how to make profit and how to keep environment clean. This type of challenges used to be there. It's all totally global scenario is changing, particularly after COVID pandemic. So slightly I had to change my style of presentation. Anyway, I still touched 1 or 2 slides. So basically, the challenges I'm going to speak in the context of price volatility of gas and crude and growing population, need for self-reliance, particularly to our country, environmental challenges continuously, improving day by day, and cleaner environment is the need of the day. So coming to population, as far as globally is concerned, it is already 1.4 billion projected, and India is going to very soon surpass China's population. I would say for petroleum industry, this is a plus point. I'm taking is a positive point for petroleum industry, although it is negative point. Almost the growth is taking place in Asia Pacific only, but historically, petrol. Okay, so energy is going to be the projection of demand for petroleum products is going to be faster than population growth. That is what is the historical trends show. So that is again, then coming to, okay. The key challenges of our country are again the three put in a triangle actually. Sustainable growth is always required. Then energy security is also one of the important parameters. Right from the first Prime Minister of India, he's harping on that point. Environmental impact, and so we have to take care. So basically, regarding sustainability growth, we have to be competitive. We have to have innovation. All the technology upgradations have to take place. And then climatic change, we have to preserve the climate. That is always, everybody knows that. And coming to challenges of our country again, these resources are dwindling, changing. Now the gap between petrol and diesel is coming down. Earlier, people used to calculate whether to go for a diesel-driven car or petroleum-driven car based on the price of the fuel and the cost of the car vehicle. But now the gaps are coming down. More people are buying diesel-driven vehicles nowadays, and of late we are seeing electrical-driven vehicles are also coming. That way, the resources growing demand change. It is continuously changing in our thing. But our country, particularly our exchange fluctuations, particularly, and depending on the oil price also, oil price is changing fluctuately. We don't know what is going to be the price tomorrow. Nobody can predict. It's a $1 million question always. Actually, so far nobody has born on the earth who can predict the oil price which is going to be next month. So that is what is because political scenarios are changing. So many things are there in this. Geopolitical situations are different. So that is what is happening. Okay. So this is another country. Our country is certainly, our still rate is not a very rich country. We are still a developing country. So we have to be it's a very important thing for us to conserve petroleum and see how best it can be placed. So coming to next point, okay. Major okay. This is the main thrust by the refineries. I don't know why it is happening. Any other? Then I is for a couple. Yeah, no? Okay. I'll go back. Yeah, no?
It's more we updated all these people.
Okay, whatever slide comes, I will tap. That is better. Then which is it? Okay. So the challenges that our country are basically maximizing the margins. For maximizing the margin, the thrust is on the crude mix. What is the crude mix? What is whether to process high sulfur, low sulfur, or sweet crudes, or heavy crudes, or high ten crudes, whatever. Then marketing challenges, exploration challenges, funding of the projects, and particularly in of course, this is gestation of the projects and project delays, and as a result of the cost overrun, time overrun is everywhere, not only in India but also globally also. And funding of the projects and efficient allocation of various energy resources, how to allocate these things, and cleaner technologies, all these things is certainly an issue for our country. It's a challenge. I'm going to talk slightly touch upon one of the important points. Major operational controls by our refineries, what we are facing on day-to-day operation, are widening of the crude oil basket. That has to be that is increase the capabilities of processing capability, because suddenly you might have seen during this Ukraine war, Russia, the crude started coming from Russia. So our capability to process the Russian crude overnight was there. It could be established because we are habitual. Indian refineries are habitual to process varieties of crudes, because time and again continual improvements or technological improvements are being taken care. So that is how we were able to process the Russian crudes of late, and then without making any dent in the margins. That is what is happening. Then ocean freight reduction, this is one area where we are concentrating. Certainly, if the crude is coming in VLCCs, 2 million barrel cargoes, then it will be always cheaper. And demurrage control is also is bothering. If a tanker is waiting outside in the sea, then we have to pay a huge demurrage. That is also so. Where for controlling that, normally planning is very important. Whatever crude is to be plant to be processed in a particular month, that has to happen. So we are always working on the tightrope box actually. Otherwise, if crude is not processed, if some stocks are lying in the tanks, then naturally the ships will be waiting in the high seas, and then we incur a large demurrage controls. This is one of the biggest operating costs that is being incurred by the refineries. And then obviously inventory control. But inventory control is very important from the point of balance sheets, particularly if the crude is procured at $40 per barrel, and suddenly at the end of the month on 31st March, the price has become $80. Then the cost of the inventory will suddenly go up. The balance sheet is changing drastically. That of course sometimes the balance sheet doesn't really depict the actual efficiency of the operations, but this type of jugglery is also taking place, particularly in the oil industry. And of course, the reliability is very important for any industry, not only for refineries. We have to minimize the interruptions, and any equipment is downtime for cleaning or annual turnaround maintenance. The time is given for 1 week, means it has to come back in 1 week. So for the precision of the planning is very important for us. So reduce the fuel loss. Fuel loss is the order of 9%, 9.5% in the refineries. But it used to be 7.5% earlier. But as the processing, the secondary processing and the fuel quality improvement programs are taking place, more and more secondary units are coming up, like hydrotreaters, catalytic reformers. This type of many units are coming. Then many distillate improvement programs, like by adding hydrocrackers, for example, where hydrogen is consumed, which is a costliest commodity of the refinery. So naturally, the refineries fuel loss will go up. So from 7.5 to 6.5 like that, it has gone up to 9.5% these days. So it depends on the complexity of the refinery. We call it a Nelson complexity factor. Any refinery which is having more than 10 Nelson complexity factor will have certainly more than 9% fuel loss. So coming to reduction in the fuel loss, I would like to stress this is also one of the important parameters for refineries challenges. That is fuel consumption. A lot of improvement, about 40% of our energy in refinery is consumed only for power and utilities. So let me only concentrate, because it is the highest chunk of the fuel is consumed in power and utilities. I thought of sharing one example. BHL, GE, Alstom, Mitsubishi, all these companies who are supplying the gas turbines to refineries are continuously doing some R&D. The efficiency of the equipment is increasing. Nowadays, it has come to the normal turbo generator efficiency is as low as 20% maximum, but the gas turbine efficiency is as low as 61%, because they are cold air, which is normally ambient air is taken to the gas turbine as along with the fuel, whereas if the ambient, instead of ambient air, suppose it is 40, the cold air is taken maybe at 30 degrees, we have a gap of 10 degrees centigrade. So because of that 20 degrees centigrade, the winding temperatures, there will be a lot of cushion available in the winding temperature. A gas turbine, for example, a flame 6 gas turbine, which is having a 30 megawatt capacity, can be easily operated to 34, 36 operated, because the fuel temperature, the air temperature has gone down, and the winding temperature maximum can go to 70 degrees, suppose. So I can easily, the air temperature itself has come down, so I have more cushion to operate the machine. So as such, the BHL or G machine will not have any problem. Machine will take care of increased output in terms of megawatts. But certainly, so this particular cold air intake and using a small cooling tower is a very good invention, and many of the refineries today do not have this type of facilities. I feel that this is a good suggestion by all these companies which are mentioning. So we should be, and also one more point was supplementary firing facility. Also, many refineries were not having supplementary. The gas turbine exhaust is about 900 degrees centigrade. It will have about 900 plus. The oxygen content is very high. It contains more than 10%. So it is certainly because of very high oxygen content and very high temperature. Simply by injecting supplementary firing in the exhaust gases, we can generate higher amount of steam in the heat recovery steam generators, which is on the downstream of gas turbine. So supplementary firing is also one of the important aspects. I feel many refineries and whoever is operating a gas turbine or combined cycle operation should follow this. This is what there is a lot of savings in the fuel consumption and also carbon reduction. So the flexibility in processing opportunity is also a key because of the changing of the prices continuously, and also gas prices. Of course, this is actually Henry Hub prices. These are not domestic gas prices which are shown here. is also globally also the gas prices are fluctuating. The fluctuation of the raw material is also a concern to our refinery. We cannot plan anything tomorrow. We don't know what is going to be the margin tomorrow. What will be the profit of the refinery in next 5 years time because of this type of fluctuations in the raw material cost itself. So that is another challenge for it. Okay. Even in the Indian basket, these PPSC data is more or less maintaining in line with the Brent crude average, you can say. And gas price, you can say, off late it has gone to 8.5% for domestic gas price, and gas price is ceiling for difficult areas, it is as high as to $12 per MMBTU. So then we have trust. We are giving a lot of trust in absorbing the opportunity crude. Opportunity crude, I mean, is a bad crude, basically. It is a challenging crude. It's difficult crude available at a lower price. All the quantity available is also low. So they are basically how to operate. That we normally take some blending crudes. Reliance Jamnagar is also practicing the same thing. The GRMs of Reliance Jamnagar are higher. Only because he is trying to process as much as possible of these opportunity crude. Particularly, what they are doing is they blend with normal crudes and process, because the inherent properties of opportunity crude as such in neat form, it is impossible to process. We cannot design a gold-plated refinery only to process opportunity crude. It is very difficult. So that much of quantity is also not available globally. So the best way is to blend it. And one of the examples is high acidic crudes, more than 0.5, more than up to 1 milligrams of KOH per barrel of crudes are called high tan crudes. And then heavy oil process. And we have some indigenously available opportunity crudes also. For example, North Gujarat crude is very high. 70% of from the North Gujarat crude is 70% is RCO, 350 degrees centigrade plus content. So like that, catalyst capabilities. We have to improve the catalyst capabilities. We are changing the catalyst recipes are also to be changing, suiting to the crudes, suiting to the contaminants in the crudes, changing. Then next coming to that major trust by oil refinery. And the last point as far as refineries is concerned is the optimizing the crude mix. We are always trying to thrust is to maximize the processing of low priced crude oils. Then switch to petrochemical. Refinery should have configurations, should have ability to switch more and more petrochemical products also. So whenever the naphtha is the demand for MS or diesel or anything is less, then people should be able to from the available naphtha or gas, we should be able to switch to petrochemicals also. After it, some of the refineries are also doing revamps to include some of the petrochemical plants already. Upcoming refineries are already planning to include petrochemical plants along with their refineries. So that type of integration has to be there. And capacity utilization, more is better. Slowdowns are to be avoided. To avoid the slowdowns in the refinery, it is a must for us to do continuous troubleshooting. And then reliability of operation, repair and maintenance, downtime is to be less. And last but not least, most important point is safety and environment. So our refineries have taken in order to control the improve the managerial controls, to control the environment as well as the safety in the refineries. They have deputed the highest officers in most of the refineries. Earlier, one officer used to see also safety and environment also, but now one dedicated general manager is posted only to look after this type of aspects. So that is the importance being given. So then reduce the fuel loss, which I have talked already. Then now the next globally, what is happening is that many refineries are switching over most of the refineries are switching over. I can see that left-hand side thing is how the refineries are over capacity because they are unable to process. Demand is less, particularly in pandemic situations and global inflation is taking place. Those times, how the margins are also dipping because the capacity utilization has fallen down to as high as 68%. In globally also, of course, unfortunately, it did not happen in India. We could manage to some respectable level of operations even that time also. Then present domestic refining capacity is then closed. You see how refineries are closing. Many refineries globally are being closed actually. If you see the closer percentage wise, New Zealand is the highest maximum affected. And of course, fortunately, in this type of data, in many data, I did not find if India is not appearing in this. There's a number of refineries being closed. Which are globally, you can see many countries are closing their refineries because of the various challenges, because of the demand and unsustained operations, all these things. So global downstream capital expenditure still is going to take place. 190 billion tons is going to spend for refinery expansion by 2030. Refining and forecast is only $2.3 million for refinery crude distillation unit during 2023, in the next 5 years' time. And the high refinery margins used to be there. Earlier, we used to expand or install new refineries based on the high refinery margin, but now that situation is not there. So people have to think many times. It is very difficult to get the approvals for a new refinery, but only refineries which have petrochemical integration and wide varieties of crude product mix can only survive. Those refineries are still able to show the margins, and they are coming out. For example, CPR refinery at Nagapattinam is the last refinery which was approved by the board of Indian Oil for 9 million metric tons, which is going to come already. Although the IRR used to be about 12% those days, but I don't think it will be 12%. They might have somehow agreed to operate the refinery at slightly lower IRR also. The board might have taken a challenging decision to approve that project. Certainly, this is particularly these are the price volatility, and nobody is able to predict also. Then coming to time overrun, many refineries, even the projects once is approved, it is very difficult to complete as per the time. If a project is approved to complete within 5 years' time, and it is taking, for example, you see the Dangote refinery, it has taken almost 7 years now to get it completed. Even now, after 7 years back, it was conceived and project was approved, and now today they are going to come some commissioning activities of offsets and CDU is happening now. So that is what I say. You see the cost from 618 kbda, this thing, so many trillions. It is to be 10 billion US dollars he has planned. Today, he has come up to almost $18 billion. The graph shows $8 billion. $8 billion. The price has, the project cost has increased because of the time overrun. So the time overrun is also a problem when it will lead to the cost overrun. So then actually the IRR will go
42,000 crores.
Unnecessarily, it is a big money for them. Anyway, this is an example only. So what particularly for people, the organizations in our country should concentrate on this aspect. We have really meticulously planned in completing the projects in time. So coming to this slide, I will skip actually because of time. You see, this is the paramount uncertainty. You see the liquid demand scenario, that triangle what I have shown horizontal, that is where we are today, sitting here. The predictions on the right hand side, so many consultants are listed. How they are predicting? There are various scenarios they are assuming. Based on various scenarios, the lowest and highest, there is a gap of 112 billion barrels of oil equivalent per day. That is the gap in the predictions by the year 2050.
But for which scenario do you vote for?
So our scenario, if we have to push the project, naturally the top one. if I am sitting the other side to counter, then we pose a question to the person who is putting, we will show him the bottom line so that he will work more and more times. Normally at the end of the time, what is the need of the hour? Really, because our population is going to increase, and we don't know still whether EVs will be adopted by our countrymen. Still, there's a lot of R&D. One or two incidents which are coming in the newspapers that there is a fire in the while parking in the parking from a car battery or a two-wheeler battery. So people are getting slightly frightened to buy, whether to buy or not 2 or 3 times. Still, I find the other day my own daughter, I told you, go for an EV, it is the latest model. No, I don't want to take any risk. So the next model will be EV. So she has simply postponed and pursued one auto gear normal car. This is what is happening still in India. Of course, it is a blessing for us, for refineries. That way, the scenario, I can say it is okay, more or less midway, an average scenario we have to carry. We have to somewhere in the average only. And see, as far as the average scenario is beating the gap, we should go ahead. That's right.
But if you take the average, you are at the 2000 level.
2000.
You are no higher than the 2000 level.
Even if you take average, it is a flat only. Almost flat.
So there's not much increase or decrease.
Decrease. Exactly, sir. It happened in front of me because I was in CPCL at the time of pushing the proposal for 9 MMTP. You could not at all justify on paper through economics.
I hope Mr. Jennings will later comment on that. But the point is that if you are taking a flat line, in terms of refinery capacity, in terms of number of refineries, in terms of many other parameters, no large change is expected.
Nothing is. I will. Okay. I think he has a few slides on that. Exactly. So another challenge is CO2 regulations. Many refineries which I was showing, where the conversions are taking place, they are trying to use their hydro heaters in their refineries and to produce the biofuels development. CO2 drives the biofuel development. And another one is vehicle efficiency and EVs. The third one is gas alternatives for LPG, CNG instead of petrol. People are already switching over to CNG, LPG, etc. Then green hydrogen is also going to come in a big way. These are the 4 parameters which are coming up as challenges in CO2 regulations. So see the refineries, how conversion capacity is going to increase. This is actually a global scenario. Compared to 2022, 50 number of refineries, total capacity, 50,000 barrels per day of refineries are being converted to biorefineries. So it will increase by 3 times to almost 150 by 2025. So it will be triple from 50 to 150 kilo barrels per day. That is what is going to come. Biorefineries in India are also coming. Actually, one 2G ethanol biorefinery at Panipat refinery was already inaugurated by Honorable Prime Minister recently. Then Bhatinda and Numaligarh, and then that Bagar are also planning some of the biorefineries. So we have already started into slowly entering into biorefineries market. But vehicle industry has really done major, real good R&D. The improvements are real worth seeing by vehicle industry. IC engines, then hybrid electric vehicles. Hybrid vehicles come long ago. But after that, EVs are also being more popular, particularly in US and USA, Europe and USA. Then hydrogen fuel cell is also being used to all these things. Efforts are to displace petroleum products only. So coming to EVs is going to be a threat to gasoline and diesel demand. Certainly, passenger EV sales, EVs are sales going to be sharply going to rise from 35.7 millions. 6.6. It used to be 6.6 millions in 2021. It will go up. Prediction is 35.7 million EVs by 2030. 2030 is not too far. So certainly some dent into that. The dent is $4 million barrels per day of gasoline demand will be decreased by 2028. So this is what is the expectation. The same thing is graphically shown here. The current scenario, the top blue line is showing the as is there is cases, but because of the EVs and all this changing the fuel quality, the graph is falling. And so the increasing those bar charts are the resultant replacement of gasoline. So global transformation of fuel outlook is it is coming down. It is not even flat. By 2049, the million barrels per day, if you see the fuel, most of the fuels are coming down. This is one of the outlook sourced by S&P Global, a consultant, as per their prediction. This is the one. Then refinery liquid product demand is also set to decline. See how it is going to decline. This is again because of the biofuel only, non-LPG petroleum product demand, how it is going to come down by 2040. World will consume more than 75 million barrels per day of products by 2020. But what will be the future? We still don't know. Still many studies are going on. We have seen various scenarios. See how the conversions are taking place. Natural gas, if you take the first graph, the use of the natural gas and petrochemical for fuel, for generating fuels and for running petroleum products. It will be flattened by 2040. It will touch that. Whereas light naphtha consumption, usage for fuels, the top blue line is for fuel usage. It is coming down by that then, and then usage for petrochemical feedstock will go up. Whereas heavy naphtha is remaining more or less. This particular graph shows that refineries should concentrate more on keeping the heavy naphtha as one of the products. They are safe. Whereas light naphtha production has to come down eventually. Okay. So then decarbonization efforts, there are three efforts, another 2 minutes, sir, I will complete. There are only three types of efforts. Efficiency improvements. One is by efficiency improvement, reduction of fuel and loss, energy consumption. That is the first and foremost attack we should do for decarbonization. Second one is hydrogen electrolysis. Third one is carbon capture of FCC in hydrogen plants. This is also one of the areas where we should concentrate. So outside refineries, other than refineries, are also many people are doing for CO2 decarbonization efforts are being taken, particularly in electricity, power utilities industries. Then India's efforts recently, this is actually reliable. This has been talked by in many forums in the parliament also. Reliable and constant alternate energy source is green hydrogen. It is already agreed by the present ministers also. Focus is on electrolysis of using electricity while producing the hydrogen to electrolysis. The electricity needed has to be from solar and wind sources only, and raw materials can be from farming and biogas or natural gas. And then clean energy is to be used for transport, steel, fertilizer sectors, basically, mainly. India already has spending around 20,000 crores. Maybe on the other day I was telling it is a peanuts compared to other global industries. That's what Mr. Jain was telling. But for us, it is a beginning, I would say. It's a good sign for me. About 17,400 is to be spent on machinery, 1,400 for pilot projects, and 380 crores for other machinery, also in pilot projects only. So again, in green hydrogen, 50,000 lakh tons of hydrogen will be targeted to be produced by 2030. You see, this is just only a feeling, to have a feeling. If 1 liter petrol is costing 110 rupees today, 120 rupees today per liter, so the same energy has to be given by hydrogen. The cost of hydrogen, that hydrogen production will be 80 rupees. That is what, as per the prediction by IIT professor, BHU estimates. So it's a good number. It's certainly an encouraging number for producing more and more green hydrogen. Then next is hydrogen converted to electricity has to be used in household. Then we can big way it will come up. So for 500 metric ton per day hydrogen cost, today it is estimated to be 100 crore, but certainly it will, over a period of time, it will come down. It will come down. India wants to be self-sufficient as far as green hydrogen by 2047. That is the target today set by them. To conclude for now, the last slide, global refineries have to face short-term, medium-term, and long-term challenges always. And then pandemic, Russian invasion, sanctions, low carbon, all these parameters are affecting the petroleum resources demand, particularly causing globally closure of the refineries taking place. However, India, none of the refineries are not much affected that way. Refineries to be innovative, they have to be resilient, and we have to be very proactive to the scenarios which is happening. And if any action is to be taken, particularly by our industry, it will happen only after 5 years' time. That is the project of my experience. So we have to be very, very proactive to face the challenges and to overcome the threats that is going to come. And Indian refineries, particularly, the only message is the flexibility of processing crude oil has to be there. The flexibility to produce product which has to be there. We should be able to change And optimum energy consumption has to be there. These are the basics for us. And lower emissions, obviously, is the need of the hour. And reliable equipment is most important. I feel that we have to do away with the repairing mechanism instead of that, to replace the equipment, because more and more new equipments are higher efficient coming down. Then safety is also very most important for surveying and taking the advantage of population growth. I feel India can certainly face the challenges, and I'm still positive to whatever challenges I'm forecasting.
Thank you, Mr. Venkatraman. Thank you very much. Can I invite Mr. Jain to make his presentation? Ladies and gentlemen, Mr. Jain retired as the ED CHT 2 years back and has 42 years of experience in the oil and gas industry. He was with IOCL at Guwahati refinery and has worked in many other refineries as well, including in the corporate office. And currently, he is the Senior Vice President of Restart Energy Bangalore. I am not personally aware what Restart Energy does. Maybe you will tell us.
Yeah, so thank you, Dr. Sudhir. Thank you, Dr. Ramugar. Thank you, Dr. Anjan, and Dr. Jain and the entire team here for inviting me. And first thing I would like to share that yes, I attended here in 1982, the 3 months course here. And yes, I attended your lecture.
All right.
And I attended, yes, and I very fondly remember Dr. Himmat Singh, remember Dr. Mohanlal.
Yes.
And because of them only now I am here and saying those. So I got a lot of knowledge, and not only we get the technical knowledge, and I would also like to say that because of this institute only we have created many good leaders, and I am fortunate to work with them. One of them was Sanjeev Singh, who was also my batchmate, and we attended together here was training. So we were together, so we are the batchmate.
That's how at IIP we always say anybody who has been through IIP is our ambassador.
Yes, exactly. Yes, exactly. So at present, after working in Indian Oil for around 39.5 years, then I also mentored one startup company on artificial intelligence. And now I am the Senior Vice President of this Rested Energy, which is a mostly upstream focused company, and it provides the business intelligence to mostly global, all the traders. And particularly it works on the short-term trading. Those kind of opportunities which are available, but now we are focusing on the downstream asset research and its management and providing business knowledge on that. And for that, I am here. Means with the Restart Energy company.
Thank you.
What is the spelling of this?
RYSTAD. Rested Energy. Reliance is the subscriber.
I know that. I think Reliance uses your
Yes, sir, Reliance.
for buying crudes.
Yes, for buying the crude. So those kind of business intelligence it provides.
Thank you very much.
Now, this Saudi Aramco, they have now inducted us for this. What he was saying, nobody can predict price forecast. They were asked us to do that job, and I'm the one of the say, project person for that.
So that they can find out how much money they can make or lose, right?
Yes, yes. The same thing what Reliance is doing. Okay, so with that, I'll be talking on the R&D direction to achieve clean energy. So one thing I would like to say, I am not a R&D person, so I can't give the direction. But definitely I am an industry person. So I can tell what industry wants from R&D. So what is their expectation and what they are looking for. And particularly we are at a very, very transition stage. There are a lot of uncertainty, a lot of confusion to oil industry, what to do in next immediate future, which is a short term, say next 10 years, and the long term to 2050 or 70 when we talk for the net zero scenario, kind of. So I'll be trying to cover more on global perspective as well as India global perspective rather than individual refinery focusing. And so based on that, yes, so what we expect from R&D will be talking. So this will be, I'll be talking R&D from industry perspective. So the global energy outlook, current industry trend, what are available, then India scenario, what are the opportunities which are coming because of the transition stage, and the industrial R&D for energy transition and clean energy. Yeah, next slide. This one? Okay, so we are here, the energy scenario. See, every year these energy outlooks are published, and people might ask, this is available last year also, last to last year also, what's the change that is happening? But really, believe me now, once I am with the state energy, we track the global events which are happening and the impact it is creating in different regions and what the actions they are taking, and then the impact on coming on the energy output. So what we are finding, what earlier used to be told that the energy peak or world oil peak is going to come earlier, which was in the late 30s. Now definitely it is in the late 20s. It is going to happen. And it is because of the faster adoption of EVs, which we used to think, or still we have got a lot of that enigma, that battery fire or this or that thing. These are part of the any technology development which happens. But I am of the firm belief that when it happens, it will be very like a sharp S-curve. The energy transition, when it will happen, it will be very fast. And we might not get enough time to get ready for that. Before that, the foreign technology might come here. So we feel that this will become very fast.
Can I make a small interruption in what you are saying? For me, this is important. There used to be a thing called the World Energy Report commissioned by the US government. And I'm talking about many years back, my knowledge is not up to date. At that time, I learned that World Energy Report, only the US Senate was a privy to that. That report was not shown to anybody else outside the US Senate. So they would also be doing something like what you are trying to say here. And in terms of whatever database or knowledge they have for this purpose. So what you are trying to do here, is it something in something of that kind?
No. It is although this US White House had also called even this year, I think last month only, they called all those business intelligence providers, including the state energy, including S&P, Bloomberg, presentation from all, and in fact they do it every year.
Yes.
And based on that, then they decide their own policy and take their decision. So just want to say one thing, that 3-4 days back only that EPA policy has been announced now by US. And they have said, I remember your story, Kamal Nath story, 30 seconds. They have said now, by 2027, 50% has to be EVs. Vehicles have to be EVs. Let anyone cry it. And when they can say it, and they will do it.
Right.
European Union.
Sorry?
European Union.
No, US. I've said it. And second thing, I think this is the very right time when this is going to mature very fast, because as and when the crisis takes place, whenever the crisis takes place, the innovation happens. And it happens very fast.
Yes.
And we are seeing that energy crisis in Europe. And that's why they are very, very aggressive on green energy. They are very aggressive on this electric vehicle. So that's what I feel that it will come very fast. It is going to happen. So that's the scene, the global scene.
Thank you.
Now coming to oil demand, what is the projection? 0.8% per year still is predicted that the global oil demand is going to increase. But after some time, it will get restricted to 103 million barrels per day, not beyond that. It will go. Because then the maturity will come. Third thing that is happening, the trend is already there. Oil is in petrochemical in advanced countries, now is coming down. You must have seen or you must have heard many European refineries have been closed. Few US refineries have been closed. All this oil consumption required there, it is now shifting to Asian countries. But their oil consumption with respect to transport fuel, with respect to petrochemical fuel is coming down. One of the most important other reason is they have raised the carbon tax to $80 per ton. making most of the refinery unviable.
In Europe, right?
Europe, Sweden, Norway, all they have done.
All this thing perhaps do not matter. The demand is very, very less.
But those are setting the trend. Remember, see, US, Europe, they set the trend and develop the technology. And once they develop the technology, make it economical viable, they will then force to other countries. That's the policy they adopt now.
Trying to advertise how backward we are.
Yes. Yeah. So because of that, now the technology development is happening very, very fast.
Now, they're also generating funds through these taxes to invest in R&D.
Exactly.
Whereas from our side, public
Yes.
investment in R&D remains relatively weak.
Right. So there is a shift in refining and petrochemical activities towards the emerging economies. Oil demand continues to grow in developing countries in sustainable development scenario. This will continue, and it will continue at least in India. The good thing is it is continuing. The peak will come in around 2030s.
But you have not mentioned this change in oil demand, which is not increasing. How is it going to affect the prices?
Price,
Which Mr. Venkatraman touched upon.
I'll come. Okay. Yes. So these are some of the facts which is happening. These are the refineries which have been closed. These are means have been closed or are getting closed by 2024. And you are observing here, most of these closures are happening in US, closures are happening in Europe, China, Japan. Okay. Now China is closing because of different reasons. He is closing the smaller refineries to make the bigger refinery.
Yeah.
So scene is different. And so what is happening? Shift from fossil oil to clean energy. This is their focus. Europe energy crisis and that aggressive carbon tax conversion. And what they are doing, they are finding that opportunity. Those closed refineries convert into biofuel refinery. That's another trend that is happening.
But the biofuel refining also needs a resource base, raw material base.
No, raw material is the biofuel. They are using that infrastructure which is available, distillation column, reactors, etc. Because those have become now idle.
Okay.
So the feedstock supply chain is separate,
Yes.
but the assets are more or less the same.
Assets, so they are reducing the cost this way.
Okay.
Their project cost is coming down this way. Now, what is happening on the other side? There is a capacity expansion taking place. 745 million metric ton equivalent capacity is coming. Okay, and it is coming in China, it is coming in India, it is coming in Middle East and Africa. So all developing countries, mostly. And now these companies, they are trying, or this country, they will be exporting the product if required to those advanced countries. Okay, but what you can't do, if in future that carbon tax and other things comes, CSIR and other things come. So those are the opportunities which I'll be talking, how India can use those opportunities, which is now a threat to other countries, might be. So, okay, so if we talk now India, so India is a growing country, and recent IMF report, if you see 3 days back, they have published IMF report that India is set to grow the highest among one of the major economy. It will witness the largest increase in crude oil demand in near future by any country. Rapid urbanization and industrialization will see around 3% per year growth in oil demand in the next decade. So from 929 primary energy consumption to roughly 1237, which is a 133%. Crude oil demand million barrel term. So you can see 5 million barrel to 7 million barrel is going to happen.
One little question. This increase in demand is because of which sector? Automotive sector?
Yeah, so because India peak is not going to come. India peak is going to come by 2030, even in the gasoline demand, even in the diesel demand, it is continuously.
And this takes into account the increase in EVs in India.
Yes, even after taking care of that.
It is,
Yes.
okay, thank you.
So now we are here, even with the great strides of renewables, energy efficiency policy, whatever India is doing, even then our bill, import bill, is going to double in next 2 decades. And the major impact is going to come on oil bill. Import dependency continuously increasing because our crude oil production is not increasing. If the demand is set to increase, this import dependency has to increase. So our continued risk on energy security is there. So we are having at present roughly 88% oil dependency. Gas dependency is around 48%. And overall dependency is also around, 48% and gas dependency is 54%. Sorry, I'm finding some difficulty to operate. Sorry, I'm going slow. Sir, Dr. Sahab bata diyega when I should.
नहीं, आप जितना जल्दी कर दीजिए उतना अच्छा है बस.
Yes, yes. So if there that energy security is a problem, so we have to take care. That's what is India trying to do. Okay, so dual challenge. You have to meet the demand, but is also there that we have to protect our environment and our Paris commitments. Everything is there. So fossil, we have to shift from fossil fuel to non-fossil or the green energy. So that all those commitments are there, 500 gigawatt, 50% energy from renewables. Then we have also committed 1 billion ton of carbon CO2 emission reduction by 2030. This is a commitment. So CCUS will become a priority to us.
This is one interesting question. See, when you replace barrels of oil equivalent with renewable energy, the installed capacity is not a direct measure because you will utilize only part of that capacity in real time.
Correct.
So how do you model that scenario?
That refinery utilization is tracked every month, and that is built into the model. Of course, the integration of biofuel
I'm saying more about solar and wind, which don't operate 24/7. No?
Yes.
If you look at your installed capacity, RE, the bulk of it is in wind and solar,
yes,
and which is not 24/7 power.
correct.
So that installed capacity of 100 gigawatt is only
It's
delivering.
taking 25% of that.
So it has to take some.
Yeah, you take some factor.
Some factor has to go.
25.
Got it.
Typically, it is 25 or 26%, depending upon that. Pieces.
Yeah, thanks.
So, of course, these are all the commitments. Now, to meet those commitments, then India has to follow certain strategies. So, strategies are very clear. Everybody knows. Enhance crude oil production to reduce your import dependency. Move towards gas-based economy from 6% present, 6.5% to 15% you have to move. Promoting biofuels and renewables, energy efficiencies, improvement in the refining process itself, then the demand substitutions using EVs and green power or green hydrogen, etc. And here the role of R&D comes. It's how to do the hand-holding and move from energy transition to the clean energy.
Just one little thought passing through my mind.
Sir.
You are, in the previous 2 slides, you have shown increase in crude oil demand, particularly for India. How is it going to affect our environment, air quality? Because you are going to combust more. We are already bad. So whichever sector that oil consumption goes to, automotive or any other, it will lead to some additional contaminants in the air.
Correct. So that's why
I don't have any data for that.
I have not tracked those data, but definitely one thing is there. So that's why India's commitment is net zero 2070, number one. Reason being, India's per capita CO2 emission is not so high. So India is taking that advantage, of course, at present. Per capita is lower. Per capita, India is very low.
I know.
So that advantage India is taking. Second thing, all those things become good or meet doable when you are able to meet your requirement. खाली पेट वाला भूखा आदमी कभी जो है उस टाइप की बात नहीं कि पहले बोला मैं अपना पेट भर लूं. So you have to meet the demand. That's why you will find here even the coal consumption is increasing in India.
I saw that.
Everything is going to happen because first you have to meet the demand side by side. So the dual challenge, that's why I read, meet the demand and be still remain the clean. So you have to work on both the front. Okay.
Thank you.
So CCS is important, green energy important, but side by side you have to make your crude oil production also to increase, gas to increase, coal to increase, everything you need it. Unlike European country where the demand is saturated now.
It's going down.
They are going down, so they can do the substitution, but we can't.
There is a gap in efficiency also. Still, we are not efficient in our numbers. So that efficiency improvement will also take care of some carbon emissions.
So, you, sir, so that's what is the confusion everywhere. If we are at one side, we are talking the net zero, this and that, green energy. So what will be the fate of this oil and gas company we are talking? People are confused. People are thinking what to do. Second thing is when to do. What to do and when to do. Okay. Now the issue is if we are not doing and some other advanced countries are doing and they start imposing those kind of taxes and those environmental constraints, that will create another pressure to these developing countries. So, right, sir. So everyone, including like Indian Oil, so I keep on tracking very closely. We talk now, we have given the motto that we are energy company. So that from oil and gas company, now we say we are the energy company. At least we have started thinking that oil and gas is not the only thing. So we are venturing now your hydrogen, we are venturing to power, everyone is trying to do that. Oil to chemicals, everyone to different areas we are thinking to create that flexibility and to keep your business model, business running. But so far, very little has been done by these oil companies. Now the gradual focus is coming on biofuel or carbon capture and other things. So now we see what is the India path, what kind of commitment it has done and how it will reach there. So if you see here, India crude refining capacity pre-end 250, we want to reach by 2030 around 300 and then 450. So continuously we are increasing the refining capacity, unlike West. Asian countries increasing, but European countries and American countries, they are decreasing. So this is the contrasting thing. Gas share, we have to increase. If we have to increase the gas share, from where the gas will come and where we will utilizing the gas. Another important. Hydrogen policy, yes, we are there. We have made recently policy, but 5 million metric ton is not a very big quantity we are talking. If you see our current country demand itself, that itself is more than 5 million metric ton.
Can I ask one more question? I'm sorry, a little layman's question, both to Mr. Venkatraman and to you. I mentioned sometime back that some years back, we had a huge diesel demand.
Yes.
Now we are going to see a decrease, particularly in the diesel engine vehicles. So we should be seeing a decrease in diesel demand in India also comparatively.
So my answer here will be, if India is going to be impacted in terms of demand, it will be gasoline first. Because the impact is going through the EV mostly.
Yes.
Now, EV, if you see India, 2/3 of our gasoline demand is in the two-wheeler. And now EV is very successful in the two-wheeler. You see, in Bangalore, I am seeing all this electric Ola. Or one side, Yulu. It is so fantastic. Crazy guy should drive it. बगल से निकल जाती तो पता ही नहीं पड़ता.
You can go even at 120 kilometers per hour.
So I'm thinking to buy one this.
No, you have just answered my question actually. The way I infer from what you said is that in India, unlike the rest of the world, the gasoline demand may come down because of these reasons, and diesel demand may not come down because the heavier vehicles can't easily come on EV.
Number one, it can't come. It will not come because of that. The range anxiety is there.
Second thing, that is a small matter. That's a small matter. better.
Second thing, the weight itself becomes very high, no? That
Battery.
battery weight is high.
Technology will,
Efficiency is
technology will take care of that.
Third thing, the India base is very high diesel compared to gasoline.
Yes, yes.
See, if gasoline is 28 million, diesel we are talking 85 million. So even if slowly it will come, it will make a very little percentage by very little impact. Whereas this gasoline impact might come much faster.
Faster than diesel.
Right, sir. Another good point is, or good or bad for India, I can't say, biofuel for the Corsia. Of course, there is some buzzword, some talks happens, but I don't know how far we have done, but definitely I know lot of jobs are being, lot of developments are happening in US on this sustainable aviation fuel. Okay, there are 2-3 refineries they have commissioned. They are continuously now making. Even flights are running. Even there was a news few days back. What airlines, some European airline, they are charging some premium and people are paying. And it is running on SF.
This is Anjan's area of work.
Yes, sir, I know. He's over there.
I think only one flight.
Flag bearer.
Only one flight has gone.
One flight, so
One flight has
Kashmir
traveled
mein gaya tha.
on SF.
Yeah. So this is
65 flights.
area.
65 flights to base.
Okay, good.
Yeah.
So far.
Renewable power, yes, we have got a good commitment and reasonably good progress is also there. CCUS, this is a good opportunity which coming. I'll share one experience of one of our fellow who went to Malaysia and what they are seeking. So R&D to support here. See, if we have to move from fossil fuel to clean energy, means we have to pass through the transition. And during this transition, we need handhold. We need the help of R&D till we reach there. So we need support in upstream efficiencies improvement. We need support for refining process till we reach to the green energy. CCUS is giving us great opportunity. I'll be talking advanced fuel strategy. I'll be talking and low carbon hydrogen is one of the areas. Sir, on the upstream side, I'll be not be much focusing but the goal is very clear. We have to enhance our oil production, gas production, and reduce the production. Important. Now, on the R&D side, R&D on the refining side means what? Whenever I see in the refineries also, low level heat, that low level heat we still lose. And it creates double pressure, means environmental impact, it is coming and we are putting that much additional firing in the furnace. Can we recover that low level heat? Second is develop catalyst to improve conversion process. One thing now is very clear, IMO is now coming up with a new regulation likely to come by 2030. They want to reduce CO2 emission from shipping industry. If that is going to happen, what will happen to that much FO?
FO has to be low sulfur.
So no sulfur sulfur nahi, CO2 cut.
CO2 का बात कर रहे हैं ना, CO2 का.
Sulfur ना भूल जाइए.
Okay, IMO 2020 is already there.
Yeah. So वो तो हो गया, sulfur तो हो गया. Now they are talking on CO2. Means although it will be converted to CNG or green hydrogen or biofuel, so where this FO will go?
So that will ammonia.
Sorry?
They are pushing liquid ammonia.
That will go to
Maybe other things also.
So means that's where another quick conversion is required. Otherwise, either the refinery has to cut down the throughput or it will be at a very throwaway price. A lot of losses are going to. There won't be even the market for that.
There will be huge quantity of bunkering.
Huge.
How will the refinery store all that?
So that's what I'm saying. R&D now. Quickly. Second thing now, this kind of R&D transition, it will not wait for time. Sir, aapka kal ka mujhe yaad hai. If our Indian R&D is not going to come up here, industry are forced to buy somewhere else. They will go somewhere else or buy the technology. So it has to be time driven. It has to be what industry is requiring.
Good point.
So that has to happen. Then the efficient hydrogen production to minimize CO2 emission during the transition in CCS. So now R&D for biofuel, though Mr. Venkat has also talked here, but this is creating now huge opportunities. Require means whatever 1G we are doing, 1G will go up. 1G will not sustain in the market because definitely it is competing with our food cycle and other things. So the 2G, 3G, those things have to come up. The SAF has to come up. So whatever we have developed, the 2G technology is not good enough. It is not economically viable. So our enzyme cost has to come down, our feed management cost has to come down. So there are a lot of R&D can be done.
Very, very good.
Sorry, sir, I am going fast.
First kar dijiye.
So these are the area: feed management, conversion process, whether through high temperature deconstruction or the low temperature process. Then the valorization process. If ever it is not economical viable, we have to see the byproducts and its valuation, how to improve it, and to prioritize which one product to go, whether to go for CVG or whether to go for biojet or to biodiesel or ethanol. Right, sir. So these are the priorities. When we come to say low carbon hydrogen, so this is creating a huge opportunity globally, and in my view or in my listed energy company view, Europe has taken a big lead here. So the hydrogen production process means different kind of options are there. What kind of research is going on? We'll have to finalize quickly which one is the best. Then hydrogen usage. This ecosystem is yet to be developed in the industry, power, building, heating or cooling, and then the transport sector will be utilized. Then storage process, because it's a high pressure and low temperature storage. So material science R&D can be done. Then the delivery infrastructure. You know, sir, in Europe, now I'll come here, 91 hydrogen pipeline.
Previous slide, I have one question on the last line. You're talking about $1 per kilogram of hydrogen.
It has to
how have you arrived at that number?
Sir, that's the motto target Reliance has. Not only Reliance.
इनको छोड़ दीजिए.
नहीं sir, इनका नहीं यही होना है by 2000 and it will happen.
Okay.
Our chairman calls this as a pool shot. 111.
111. Yes, yes.
$1 for 1 kilo in 1 decade.
1 decade. That's why there is a target by 2030.
No, it's good they have set up a target. That's very good. So we can try to meet that.
Sir, this is not India target. Even the global target is that.
And this is for green hydrogen.
Green hydrogen.
Yes, naturally.
And current hydrogen production cost is $2 with proceed.
And green hydrogen is $4.50.
$4.50. Okay. So from $4.50, it has to come down to $1.
That's why.
And it will happen.
Like what Zero Bhai told about this mobile call. इसको पैसा जो है ना postcard से कम और zero ही हो गया.
Sir, now you see in Europe, 91 hydrogen pipeline projects are on with 28,000 kilometer pipeline. Means they have a plant where it will be made and how it will be supplied. Okay. Sorry.
अगर सब थोड़ा सा जल्दी करना पड़ेगा.
कहाँ गया वो?
घर साहब का लेक्चर नहीं होगा फिर.
वो उठा के ले गया वो सब.
So sir, there is a huge opportunity, huge export opportunity, and India is
ईशा ने बोला यार 9 बजे की बात.
solar intensity, everything is there. So here in India can encash very quick. क्या रहा है? सर ये टाइम तो आपको देना पड़ेगा ये डिस्टर्ब.
घर साहब का उतना कब कर देंगे?
नहीं हम लोग लेट बैठ लेंगे कहीं नहीं.
हमें कुछ अब कहना थोड़ा ना रह गया, सब तो जैन साहब ने बोल दिया.
Okay, so these are now CCS. So CCS are what happened recently. Our team went to Malaysia and Indonesia, and they produce a lot of crude oil also, and they are seeking, in fact, the opportunity where to store the carbon dioxide. Now there is a business economy which is talking. They are producing the CO2. It can be transported by either ship or through pipeline. So there are independent carrier being developed for shipping or transporting CO2. And independent storage facilities are coming up where you can store it at around 800 meter depth at subcritical condition of CO2. So if any country which is having say abandoned say crude oil well which have gone dried up can be utilized. If there is a saline depth of say these wells are there, can be utilized for that. So one thing is a different method to capture that CO2. Second thing is how to transport it and how to store it. So this can be a good opportunity. Business model can be developed for India itself. And those countries are asking where we can store.
मोदी जी कहाँ से?
हाँ, चलो आप ही open करो. So this kind of the world over the work is going on. By 2026 and 2030, lot of projects are coming on this issue of whole world and different kind of technology. So huge investment is going. चलो मैं बोलूंगा आप करते हो. So now the green power, though India has done a great success here, but the market is yet to develop. Now we are almost reaching to the saturation. From reaching now 175 to 500 is a big chunk. Start from 0 to 175 was easier. Now it is a more challenge because now the impact is coming on grid side, storage side. So more and more areas available for now R&D in this area. Battery storage, grid management, discom management, pumped storage. Now this is also now picking up very fast. Then fuel cell, other things. So just to summarize, so yes, India is on a very important path, transition path. This energy transition is creating a lot of opportunity for business model as well as for R&D purpose. So we can work together. Energy transition is there now. Development of clean technology is required. Contribution in the entire ecosystem, not only the production, but feed management, cost reduction in different areas is required. And the hand-holding right from now till we reach to the net zero target of 2070. That's what I think. Thank you.
Thank you. Thanks. So we can now have Dr. Garg.
Yeah, I don't know whether we didn't need to hear me.
Since it is in my agenda, so I will have to go.
5 minutes.
And Dr. Garg needs no introduction. Yeah.
You want me to do in 5 minutes? I don't think I can sit and speak, so I'll try to respond.
Good. That was very nice.
Thank you.
Yeah. Respected Singhal sir from Venkat, Jain sir, and my own IIP family. I don't know how to.
I'm also a family.
Yes. Well, actually, it's like a homecoming to IIP, and more importantly, from this hall, where I have very strong and very happy memories. The renovation all the way to the director's conference and many more things. But anyway, emotions apart, we're going to talk about something more serious. And this is what we believe in Reliance perhaps could be the future as far as the refining industry is concerned. Just a small disclaimer which we will see in all Reliance lines and by lawyers. I just summarized it in one sentence that in case you practice whatever you learn and it doesn't work, you can't sue the company, but you can sue me. So that's what it says. So you don't have to read it. Now, this is what we are going to talk about today. And I think it's kind of a summary of what Venkat and Jens have mentioned. What we will do is we will start where we are today. And you can hear me at the back? Okay, so we'll start where we are today in terms of the existing refinery and its configuration. I don't think coming from Reliance, I cannot but speak about the iconic refinery in Jamnagar. I think Venkat already talked about a couple of times. And those of you who have been there have had a privilege to see the world's largest refinery in full action, even during COVID time at Jamnagar. Then from there on, we'll talk about what is actually, affecting this industry and the whole term of future sustainability. Okay, so we'll try to define in the real context of today's discussion, what is sustainability? And from there onwards, what is the role of new energy? Okay. And then, of course, the 5 pillars on which the refinery of the tomorrow would stand. And believe me, what Venkat and Rajat said, all of this is going to happen in the next 10 years. It is all going to happen in the next 10 years. And that 10 years from 2023 to roughly like 2035 will decide how the Indians will live on 2050. So our children and grandchildren's future depends upon what our scientists in IIP do in the next 10 years. So let's talk about where we are today. Can we actually close that top black strip there? It's actually covering part of the title.
Vishwakarma Sahab is seeing.
I think you just have to click that. I don't know how you do that.
The top bar ki wali.
So, can you click the first one?
No, anybody is seeing this presentation outside? Then I think it should be there.
Leave it go first. Don't throw anybody. Oh, no.
It will divert.
I can say
I think something.
I'm just fixing that. One second. Under control.
I need this.
फिर आप यहाँ बैठ
No, I am not sitting. You can. So basically, where we are today is essentially the whole feed to a refinery is the old carbon, which has been existing below the ground for a few million years ago, which is the old sun. And we have dug it from the ground and we are processing it in a refinery. So it's essentially fossil crude. Okay? This is where we are today. And this carbon from under the ground comes above the ground. And as Jen Saab said, 8 to 9% of that is actually consumed in the refinery itself to process the feed to the final products. And the products are essentially right now, more than 70% of the products in a refinery are fuels. Whether it is gas, like LPG, gasoline, diesel, jet fuel, marine bunker fuel, and so on and so forth. Very little in terms of chemicals, lube oil, solvent, and specialties. Okay. So whatever we know is polyethylene, polypropylene, maybe MEG, PVC, etc., etc. And the processes that we actually employ are what is called as the primary units, the secondary units, and the tertiary units. The primary being the crude distillation, vacuum distillation. The secondary are the hydroskimming, the SCC, hydrocracking, etc., daylight coking, visbreaking, and the tertiary is basically to clean up the final products to meet the end specifications in terms of sulfur, in terms of aromatics, in terms of any properties that you're looking at. So the current business of the refinery, if you ask me, is basically to supply and market transportation fuels to meet Euro 6 quality of gasoline and diesel. Go ahead. From there, let me actually give you a bird's eye view of what we have in Jamnagar. It is by far, by any stretch of imagination, the largest refinery in the world, processing close to 1.2 million barrels per day of crude oil, which is roughly about 70 million tons per annum. Almost more than 35% of the Indian total refining capacity at one single site. Divided into two refineries, the old refinery and the new refinery, each of them 35 million tons per annum. We have got two of the world's largest fluidized catalytic cracking unit, each one of them 220,000 barrels per day. The second largest is only 60, is only, about 60% of that capacity. Very large two cokers, captive formers. One of the most efficient refineries with an energy index of more than 63. It is the topmost in terms of energy efficiency index. One of the most complex, we talk about Nelson Complexity Index, I think most of you know, but there is Nelson Complexity Index. This is the highest in the world, 21. And the most important part, as we speak today, right in Jamnagar, 17% of the crude gets converted to petrochemicals. So whether it is polyethylene, polypropylene, MEG, even paraxylene, benzene, and so on and so forth. But if you take the naphtha, the light naphtha together, which is then shipped to other sites like Hazira and Baroda, the overall, company-wise, corporate-wise production, crude to petrochemicals is more than 26%, which is the highest in the world right now, except in China. China has actually gone up to even 60%. And as you know, we have actually one of the most unique plants in the world, which is called refinery of gas cracker, ROG cracker.
Sir, do you know how they are converting 60%?
China.
China, how they are converting that?
Hangli.
Hangli.
Yeah, that will take another 2 hours for me to explain.
During dinner time, huh?
Very unique configuration. Designed to convert crude oil to petrochemical. And the other one we start with Zhang something.
Jiang.
That is almost 85%.
55.
In fact, Hindley is already producing 4 million tons of paraxylene.
Dedicated conversion facilities.
And in the next 5 years, China will convert itself from a net importer of paraxylene to a net exporter of paraxylene.
Yes.
Which has shut down the shivers down the spine of most of the paraxylene producers, including Reliance. Our paraxylene capacity survives on China's demand. Right?
How fulfill their energy demand because it converted crude oils into the chemicals.
The overall capacity is.
This is in addition to that. It's in addition to that.
Over and above.
The fastest adoption of EVs are in China.
Yeah. But in addition to their fuel demand.
Yeah. They are expanding even their refining capacity.
Yes. But you see, there are two unique technologies operating in Jamnagar. And I'm not saying that because I belong to Reliance. In fact, I belong more to IIP than Reliance. Okay. But I think as an Indian, we should be proud of it. Refinery of gas cracker is what Reliance has shown to the world, that rather than burning your entire fuel gas in the furnaces, use it to produce olefins. In a refinery, I think we got two stalwarts from refinery here. In a refinery, you can never expect to produce ethylene. Am I right?
Yes.
2 million tons of ethylene is being produced in Jamnagar. 2 million tons. And that goes into make LLDP, HDP, as well as MEG.
The coker of gas goes into that stream?
Yes. Entire off gas, including FCC off gas.
So these two off gases are making that.
There are 9 streams which actually combine together to go to ROG.
These two are the major. Right?
In fact, by doing that, even what I feel my gas calculation goes, by diverting that off gas to petrochemical, Reliance has also reduced their CO2 emission.
Yes.
Has to be, no, because also what happens is when you fire off gas in a furnace, in a burner, your efficiency is much lower than when you fire pure engine.
Yes, that's what.
So basically,
winning twice.
basically we have converted, we have maximized, reduced scope 3 emissions.
Right.
Yes.
You have reduced scope 3 emissions. You have brought the scope 3 emission into scope 2 and then brought it down.
And the other unique part is the gasifier.
Petcoke.
Those of you who have never been to Jamnagar, is open invitation. Please do come. You come and have a look
All
how things are done.
working now?
Eh?
All gasifiers?
All gasifiers are working.
9 out of
Averaging around 80 days.
80 days.
Similar gasifiers were put in South Korea by the same company. 1/3 the capacity. And the entire gasifiers were shut down because they didn't work. And it is a wasted investment. So we also thought that we had done a blunder. But Reliance is Reliance. They made it work. All the
But the economics of petcoke gasifier at higher crude cost, is it viable?
वो हम नहीं बता सकते.
Now there is a question.
Jan sir, the answer is when we are able to deliver a desulfurization solution and the petcoke is ultra low sulfur, it will be the best you've seen.
But petcoke is not ultra low sulfur.
No, जब उसको ultra low sulfur बना देंगे हम लोग IIP से, तब देखेंगे. तब economics के result और कुछ होगा.
Because I was hearing that kind of thing.
It's a real challenge.
It's actually a bottomless refinery, Jamnagar. There is no marine bunker fuel.
Yes.
So you are talking about marine bunker fuel. Jamnagar, the largest refinery in the world, doesn't produce any marine bunker fuel. No FO.
No FO.
No black oil.
No IFO, no MFO.
It is a bottomless refinery.
Coker is there. Coker. Yes, yes.
Coker to petcoke gasification.
Petcoke to gas.
All the 5 hydrogen plants in the refinery are shut down.
Gasifier.
So the syngas coming from the gasifier is partly shifted. You go through a shift converter to convert CO to hydrogen. And that hydrogen is more than enough to run all the hydrogenation plants in the refinery. And the rest of the syngas is used to actually run the combined power, the CHP, as well as running all the furnaces. And that is CO and hydrogen. And part of it is used to make synthetic natural gas.
So your furnace is not require any natural gas? That gasifier energy itself run?
The syngas from the gasifier runs all the furnaces.
So Reliance is not importing any.
And after cleaning that syngas,
From mine wash.
methanol,
Yeah, ethanol.
so rectisol process. So zero sulfur. So no SO2 emissions either from any of the chimneys. And then the east-west pipeline that was put in to get the gas from east to west, from Kakinada. Gas did not come out of those wells, right? So now this synthetic natural gas is pumped the other way around.
Very impressive.
You can imagine what innovation can do. And the biggest innovation in that refinery is the BRU from this institute.
This is
Benzene recovery unit. That unit has become so critical that if that unit gets shut down, the whole refinery will get shut down.
Why?
You'll not be able to meet Euro 6 specification of gasoline anymore.
No, gasoline only, no, you can push to naphtha outside. No, why refinery will shut down?
नाफ्ता बेचने से तो नुकसान है.
नहीं, नुकसान है, रिफाइनरी बंद होने
कहाँ बेचोगे आप नाफ्ता? नाफ्ता को मार्केट एकदम खत्म हो गया.
देने के लिए बिना हाइड्रोट्रेटिंग का.
Yeah, I agree, sir. What I'm saying, if I am not making gasoline, economic ground.
बॉस आज की डेट में, you know how much is the crack between gasoline and crude?
Very low.
$40 a barrel, boss. Where are you?
what हो गया?
आप किस दुनिया में हो?
नहीं ठीक है.
नहीं gasoline
डीजल का कम हो गया.
60 तक गया.
$40 a barrel is the crack between gasoline and crude oil.
Yes, sir.
And you know, I mean, keep it within the walls. We have shut down 2 of our paraxylene trains to make more gasoline.
Yes, we'll convert.
How do we meet the spec on that gasoline? Both in terms of sulfur and benzene.
Only BRU.
BRU.
Yeah.
That unit which was designed for, I forget the capacity, I think Sunil can say, but it is now operating at 150% the design capacity, 150.
50.
Now it is running at 1 TPA, 1 million tons per annum.
The gasoline market.
Same unit, same unit, without revamp.
Just sweating it.
रिलायंस हमने जब कमीशन किया था, कमीशन करने के तीसरे दिन वहां से खबर आ गई, बॉस ये हो तो क्या, अभी 100% पे करके 120% तक लेके जाओ. ऐसे डिमांड आता है. Anyway, but other than that, actually, very low water consumption because there is no river. So the entire water requirement of Jamnagar is met by desalination, which is the most expensive water you can think of. And in addition to that, that site is the largest mango grower in the world.
Yeah, हम भी खाते हैं सर. मैंने खाया एक बार. अच्छा था, very good.
The largest mango growing site in the world.
Mango trees.
And now, actually, in another 3 years from now, that will also boast of the largest zoo in the world.
अच्छा.
Behind the ROG cracker, we are building the largest zoo. So now, coming on to why we need to talk about all these things today, is actually the greenhouse gases. Basically, CO2 and methane, these are the two major greenhouse gases, out of which, although the potency of methane is higher, but the quantity of CO2 is much higher. So basically, whenever we burn fossil fuels, which have been lying from a couple of million years ago, which is old carbon, when we bring it to the ground and burn it, we actually tend to increase the net CO2 level in the atmosphere. And we are already threatening to go at around 430 ppm CO2 in the atmosphere. And we are just about the tipping point. In fact, IPCC has already issued a red alert that if you go any beyond that, then we will not be able to achieve 1.5 degree cap on the increase in temperature. So we are just about there as we speak. So basically, we're talking about global warming, and that actually will result into climate change. So basically, there are three ways that our industry has to be able to achieve, to be able to contribute globally in terms of reducing the greenhouse gas emission, which you call as scope 1, scope 2, scope 3, and I'll get into in more detail later what scope 1, scope 2, scope 3 is. And ultimately, overall, to be able to achieve the net carbon zero targets, which all oil companies have set. In fact, Reliance has set 2035. And the idea here is to be able to make sure that somehow we eliminate 40 gigatons of CO2 being emitted into the atmosphere right now. And basically, the pathway towards that are basically on 4 pillars. Power, to go from fossil to renewable. Mobility, as we spoke, from internal combustion engine to electric vehicle. Refining, from fuel to chemicals. And finally, economy, from a linear economy to a circular economy.
इसमें एक expansion का कोई declare किया था, ये सब बैकआउट हो गया क्या?
कौन सा expansion?
एक और additional refinery लगाने का बात चलता.
वो तो 10 साल पुरानी बात है.
Nobody is talking.
I don't think Jamnagar will add any further refining capacity. So coming on to, I hope I didn't skip any slide here. Coming to actually those of you who do not know or are new to this terminology of scope 1, scope 2, scope 3, the whole world is breathing, eating, sleeping around these three things. Scope 1 is actually whatever CO2 you emit to the atmosphere and converting to products. And fortunately, if you talk about, let's say, 100 tons of CO2 being emitted, only 10% of that is by scope 1, fortunately. So it's not a big deal, a big target to achieve. And the two major contributors to CO2 into the atmosphere from a refinery are fluidized catalytic cracking unit and hydrogen plant. And of course, gasifier is also a huge one. Okay, I mean, just after we have added the gasifier, the entire CO2 emission from Jamnagar site has gone up by 25%. 25%. So it's not small. So basically, whether it is fuels, whether it is chemical lubricants, roughly it's about 10%. And those of you who already know single sub, we actually way back in 2008 at IIP presented the first very paper in a refinery technology meet on CO2 emissions in a refinery. And when MS Srinivasan was actually chairing that session. And when we put in that paper, he was surprised, iska kya jarurat hai? And I had a student from Bich Pilani, who was, we used to have them for 6 months. And he put together a brilliant student, and he did some work, and it was fascinating. We converted that into a PPT and made presentation. I still remember that our team was in Cochin, and nobody used to talk about it. And we came up with a thumb rule of about 0.4 tons of CO2 emitted into the atmosphere per ton of crude oil processed, average. Again, depends upon the Nelson complexity and so on and so forth. The scope 2 is the utility consumption. That means in order to do this, the utilities that you consume, whether it's from the grid or in-house, the CO2 that you emit from there, as well as the chemicals and consumables that you use. So if I'm using catalyst being produced by UOP, the CO2 that UOP emits in order to produce that catalyst is also accounted to my account. Because if I wouldn't have used that catalyst, UOP would not have produced that CO2. Might look stupid.
Profit sharing?
No, it might look stupid, but if I'm using some product and I'm emitting CO2, that product, whoever supplied to me, is more responsible than I am.
Yes, the GST वाला concept यहाँ डाल दिया. हाँ, वही सब. Yeah, GST. Yeah.
What it means is that the oil industry doesn't have only the onus to eliminate CO2 emission from within our operation, but also the operation of our suppliers. Are you getting my point? So actually greening their operation is a bigger responsibility now for us, for which we have no control. So that is scope 2. And when we are talking about this net carbon zero, which everybody talks about, right? And even Prime Minister has announced net carbon zero. It's only scope 1 and scope 2.
Scope 3 is funny.
Scope 3 is not included in net carbon zero. Otherwise, Reliance will not be able to meet it by 2035.
I was thinking it is part of it. हाँ नहीं है. सब इसी का फायदा ले लिया.
Then don't quote me. Don't quote me.
नहीं, हाँ.
ये Reliance वाले ने कहा था.
ना, अच्छा ये मुझे पता है. Scope 3 नहीं है.
Scope 1 and scope. And that is why you have these companies, क्या नाम है उसका ISSC, etc., who are now coming up with this concept of mass balancing and stuff like that. So if you're buying something by mass balance, he can tell you ये green है. तो ठीक है, I'm buying a green product. So all these tricks have come up, and people are making money, right? Then you have scope 3, which is the real. More than 85% of the CO2 which is emitted is because of scope 3. In other words, if I don't produce diesel, the guy who's using diesel will not produce CO2. So even that CO2 is attributed to me. 85% of the CO2 emitted by an oil refinery is because of scope 3, because fuel is the major problem. So if you're producing CO2 in your kitchen, that is also attributed to the refining industry. Because if I don't give you LPG, you will not produce CO2 anyway. You'll find some alternative.
No, that is also not go to in there. That's also go to the catalyst producer, because they provide the catalyst. As per your logic.
Very,
I didn't put these rules in. Right?
very interesting.
This is very interesting. So, actually, if you ask me, our technology BRU reduces scope 3 emissions by 15%. Because that benzene, which would have gone into the gasoline pool and being burnt as a fuel, is now being sold as a chemical.
तो वो केमिकल भी तो फिर इसी स्कोप 3 में आ गया. कहीं भी हो गया बेंजीन तो.
बेंजीन का पहले भी बनाओ,
वो कन्वर्ट हो जाएगा.
वो तो आप साबुन से बाहर धोगे. बेंजीन से क्यूबिन बनाओ.
क्यूबिन बन गया नहीं.
It will get fixed. That carbon is fixed. Even the good old, bitumen is actually a great form of carbon fixation. People don't understand this.
Yes. Bitumen is.
We are buying bitumen from abroad. Why can't we actually make high quality bitumen in this country that is straight carbon scope 3 emission reduced? Straight. I've been telling our own refinery bosses of choro, but it's too late now.
Even polymerization, petrochemicals.
Petrochemicals is all scope 3.
All scope 3. You are reducing that much carbon. आपने हटा दिया system से. And hydrogen, you utilize that.
You know, from BRU, how much benzene is being produced? Give me a number.
आपका तो size ही इतना बड़ा है तो number ही बड़ा ही होगा. Nothing.
200,000 tons of benzene is being produced.
100,000 tons.
Which is a typical capacity of an aromatics recovery unit, even bigger than that, which is a byproduct, by the way. It's not the main product. And the main product is the raffinate.
And the BRU is small and compact. I compare it with the.
Anyway, I need to move on. Yeah, I think Dr. Singhal sir is getting impatient. Okay, so it's so we are talking about new energy now, and I think everybody has talked about renewable power. But what I would like to tell you is solar and wind are here to stay. They become competitive. In fact, not only the recurring cost, but also the captive cost of solar and wind are very competitive. So this is a good news for electrification of the global economy. Hydrogen is still a pain point because most of the hydrogen is either gray or brown. But there are 4 colors that you can choose from, either green, blue, gold, or turquoise. A lot of work is being done on methane pyrolysis. We need to see how it goes. Gold is the biomass, so this is very exciting, from which biomass gasification, if you can produce hydrogen. Then blue, of course, the major thrust is green, if you can produce it from electrolysis. Carbon capture and storage, I think Jen Saab has already mentioned. And bioenergy, whether it is 1G, 2G, 3G, or 4G. Reliance has, of course, invested very heavily in 3G. We are the world's largest raceway ponds in Jamnagar, in a place called Garba. And as you very rightly said, the earlier idea was to convert algae to oil. And now the whole thing has changed into a biorefinery concept. All the way from proteins to artificial silk, to artificial leather, all kinds of things.
How much algae production is there?
Oh, that I don't know.
Approximately.
No idea. But these are very large raceway ponds.
No, these are large, so approximately. Your guess.
I have no idea. I can let you know. But the idea is to take the CO2 from the refinery and grow the algae. So going from there, the transition is, the fundamental new energy and net zero to part 2, which is so this makes so look very simple, boss. But it's like having a car which is 10-year-old. I still remember Singhal sir ने मुझे जब अपनी Fiat थी, तब इन्होंने कहा था कि बॉस निकाल दो, नहीं तो ये बिकेगी नहीं. And in 2002, I actually heard him and I got rid of that. 2 साल के बाद तो it would have been sold in a kilo basis, right? तो अगर आपके पास कोई 10 साल पुरानी चीज है, वो पैसे मांगती है. If you want to even maintain it or even refurb. So today refineries need refurbishment to go from fuel to petrochemicals. So COTC, what it stands for is crude oil to chemicals. This is where we have to go. Why? As Jen Saab said, we are definitely going to see gasoline peak at 2030. People after 2030 will not be using that much of gasoline. Similarly, diesel, in fact, we believe 2040, maybe 2045. But let me tell you something which perhaps most of you would not know. And I've been watching it with great interest in the last 2 years. All the buses in Navi Mumbai are electric.
Yes, Tata Motor is not doing it. Many buses.
All transport buses in Navi Mumbai are electric. The Indian Railway has actually come down to its diesel consumption of less than 2 million tons per annum. Full electrification.
Becomes zero by 2030, no?
They are only electrified.
Delhi Metro, the entire public transportation, mass transportation system in the world is mostly electric.
Yes.
But sir, electrification of railways has offset that emission to power sector.
Correct. But one day, Sunil, we might replace that with solar. And India can do it. It may not be Europe. क्योंकि वहां तो सूरज ही नहीं निकलता. But we have enough sun. So see the sun outside.
I can use some numbers if you want. You see, 1% of total incident solar energy on the earth is enough to meet the entire earth's energy demand.
Yes.
Yesterday, that Rajasthan is such a potential that our whole energy demand.
The only thing is,
Transmission. Transmission.
you cannot do it till you keep on importing solar chips from China. You have to produce single crystal silicon in India. And at a much lower price. And to be able to understand how to maintain these mega solar producing stations. But it's only 8 hours. So what do you do other time? So you have to actually develop energy storage devices like batteries. So these guys have gone out and bought out lithium works, Faradian. So, I mean, Reliance is looking at it in a very different way. Mostly sodium ion, maybe a combination, we don't know. Okay? The jury is still out. But actually, there is a lot of trust to build battery storage capacity. To be able to achieve 100 gigawatt of solar energy production in Jamnagar. The construction work has already started as we speak. There is already steel on the ground.
BioCell already developed the aluminum-based batteries.
Yeah, aluminum, yeah, but that's from Russia. I don't know where it is.
No, Israel.
I think aluminum air, I think from Israel, right?
Israel.
So basically, how do you, so ultimately, if all of this transition has to happen, one thing which will take a hit will be the lube oil production, because you don't need that kind of lube oil for electric vehicles. Number two is, this is something which is highly controversial or debatable, or people, it all depends on which side of the table you are. This is a prediction through the glass ball. By 2050, the overall world refining capacity might fall down to 25 million barrels per day. You might shave off 75 million barrels per day of crude oil requirement. Why? In order to produce petrochemicals. So right now we are averaging around 10% in India. I had to go to 18%.
सर ये नंबर बहुत ज्यादा होगा 18 नहीं और
So
ज्यादा
18 million barrels per day will go to chemicals. So the CO2C conversion percentage will go up to 72. If you have to target that, overall, the crude oil capacity will come down. If the whole world goes to electric mobility. But the entire crude oil will be required only for petrochemicals. And here the problem is that it's a highly competitive business, petrochemicals. One thing with the advantage with fuel is that the fuel is a local market. It's an Indian market, right? Petrochemical is an international market. So what Saudi Arabia or Saudi Aramco is doing in Korea with gas oil is affecting us.
they will dictate the world.
So as you know, Saudi Aramco has bought out S oil. They own S oil.
Right.
And they are actually putting up a 4 million ton per annum petrochemical plant
Yes.
using their HSFCC technology, that downcomer. And crude oil for Saudi Aramco, you know the price.
$8.
So they have a huge
market.
feed benefit. So nobody can compete with that. Nobody can compete with Saudi Aramco in terms of either gas price or crude oil price. So these are the threats that you have. These are real.
I think the geopolitics there actually will already start playing out. You've seen the OPEC production cuts that we unilateral.
Yeah.
That is in this direction. It is trying to precondition the world to crude availability decline so that it forces the world towards chemicals.
In fact, I remember right here in our Rajraj Kumar Stadium, I think way back in 2005, I guess, I think somebody here might correct me if I'm wrong. I had invited MS Srinivasan on 14th April, IIP Foundation Day. आपको याद है? I think some of you might remember MS Srinivasan, who was additional secretary. They later became secretary. आप तो जानते होंगे
Srinivasan sir, I know him very well. Petroleum Ministry.
He was petroleum secretary.
Petroleum Secretary.
Before that, he was additional secretary.
Yeah. And
Yes, yes. I know.
yeah.
I know.
So he came here, he delivered a beautiful lecture. At the end, he said
He becomes
that the OPEC chairman in 1996 I forgot his name. I think he was from one of these African countries. He even came here to visit us, Simon Dokaro.
Huh?
Simon Dokaro. He said Simon Dokaro in 1996 as an opening remark in the OPEC committee meeting. He said that stone age did not end due to lack of stones. You remember, Bhaskar? Stone age did not end due to lack of stones. Iron age did not end due to lack of iron. Similarly, oil age will end much before we will finish off the oil underground. And that will be because of global warming. He predicted that in 1996 and coming from the OPEC chairman. And MS Srinivasan mentioned that in 2005. And in one of the petroleum congresses, I think in Johannesburg or somewhere, there were two guys on the dais, Dr. Anjanray, the chairman of ExxonMobil and the chairman of Saudi Aramco. वो क्या नाम है उसका जो oil minister है Saudi Aramco, Saudi Arabia का. They were actually on some what you call plenary session, and they opened it for questions. So I asked the same question. I made the same statement that Simon Dokaro said that. So what is your view? So one is a large major oil company, ExxonMobil. The other is the producer. So you know what the ExxonMobil chairman said? I do not know whether it's a technical question or a political question. So I'll stay away from answering it.
That is the worst. That is the answer. That is the answer. That itself is the answer.
I think somebody from IIP was also with me at that time. And the oil minister.
DV Naik, single sir. Excuse single.
Sadiq Singhal.
DV Naik में last in the
Sadiq Singhal was there. And you know, oil minister क्या बोलता है पता है? Oh, we don't care. We have enough oil. We'll keep on producing oil, so we have no problem. Any of his statement will shake up the oil market, right? Anyway, so as far as the abatement via scope is concerned, so how do we go forward? This is just a summary of the R&D ideas. To get rid of scope 1 and scope 2, which is basically to achieve net carbon zero, we have to green the feed. We need to maximize biomass to the extent possible, whether it is solid, liquid, or gas. Okay, biomass. So whether it is compressed biogas, or whether it is bio oil, whether it is vegetable oil, or whether it is waste biomass. We need to maximize waste plastic to the extent possible. I'm really very honored to say that this is the institute which started all of this. We started working on waste plastic in 2002. When nobody knew about it, nobody even bothered about it, right? And we set up this pilot plant way back in 2006 and the demo unit.
Much earlier, Dr. Bhattacharya was also working on some of this.
Yeah.
Much earlier.
But now people talk, given different terms, sustainability, circularity, all kinds of stuff, right? Similarly, scope 2, that can happen only when we replace fossil power with the renewable power. And similarly, scope 3 will happen when we convert oil to chemicals. And this is what we see as a refinery of tomorrow, oil to chemicals. More than 70% of crude being converted to petrochemicals. I know it's not easy, particularly with the existing assets that we have. Second is electrification. To the extent possible, people are also talking about electrification of steam crackers. There's a large pilot project going on in Europe with a consortium of 6 companies which are trying to electrify steam crackers. Hydrogen, basically green hydrogen. Renewables, maximizing biomass. There are challenges on biomass. It's not that easy. It's easy to talk about it, but making it happen has its own challenge. In fact, last week when I was in Jamnagar, I made it a point to see the bioenergy research center that Jamnagar has opened. Reliance has opened. It's called Bioenergy Research Center. And they called 6 Nobel laureates from around the world to review the new energy and bioenergy initiatives of Reliance. Okay, I'm not a Nobel laureate, so I don't get invited in that. Okay.
I thought you were one among them.
No, but it was headed by Mashelka and 6 Nobel laureates. So they reviewed the initiative and they gave their comments. I do not know, but they did visit the Bioenergy Research Center. And I visited the next day just to see what it is. It's very far away from the refinery. And I could see 5 huge mountains. When I asked them, ये सब क्या है? तो ये बोले ये मूंगफली का छिलका है जो गुजरात से सब उठा के लाए.
Sure.
And from there they are producing pellets and what you call briquettes. And these are being burnt in Hazira, in the power plant, at the H and in Patalganga. So they're greening the carbon inlet into the boilers.
ये नारियल के छिलके नहीं है green the question went वाले.
See, this biomass energy center, the major focus right now is to be able to create systems and procedures to be able to collect. The problem is that it's totally unmechanized industry. And you won't believe it that we don't even have machines of those kinds. So I set up a meeting with the center with CSIR-IIP Durgapur. And those CSIR-IIP Durgapur engineers didn't even know what hit them. जब इन्होंने कहा हमको ये मशीन चाहिए, वो मशीन चाहिए, ऐसा चाहिए, वैसा चाहिए, तो उनको समझ में नहीं आया बोल क्या रहे. Then they showed some photographs of US machines. तो ये इसको इंडिजिनाइज कर सकते क्या? So that the collection cost comes down. There are many components to be able to make biomass a commercial entity. It's not something that you सड़क पे पड़ा उछाला हो जाएगा, ऐसा नहीं है बहुत.
Kal sir, I was telling Anjan Ray one day, in 40 years back, once we had talked to the planning commission, I had suggested to them, you buy gobar, give it a price, 1 rupee per kilo for biogas and other things. And they all laughed at me.
Today, Chhattisgarh is doing that. We heard this in our 2 rupees a kilo. 2 rupees a kilo in
I had suggested that to the planning commission in a planning commission meeting.
In fact, there's a very interesting anecdote. Last week when I was in the Bioenergy Research Center, Anjan, they put 2 very large biodigesters, complete with PVSA, everything. I thought, where is IIP here? Pressure cum vacuum single absorption pura laga hai. So I was telling them, boss, what are the improvements you could do based on my experience in working here? Then I asked them, gobar kahan se laoge? You have to start off, right? In terms of the methogen. Well, that is very simple. फिर वो ले गया मेरे को. Huge amount of cow dung and all kinds of dung. बोला ये किधर से लाए? बोले we have animal kingdom here.
elephants, yeah, wo.
So we have 100 elephants.
From the zoo.
So we have huge number of animals there, all kinds of animals. तो उनका सबका dung लेके आ गए. So now बोले self-sustaining है ये. This is how Reliance. Now can you imagine? Can Indian Oil operate like this? No. ये Reliance का uniqueness है boss. Cow dung चाहिए तो जानवर भी पाल लिए.
हम सोचेंगे हमारा
जानवर पाल लिए, अब उनको ठीक रखने के लिए you need veterinary scientists, all kinds of people. तो मैं गेस्ट हाउस में था. I always meet one guy who was always there. तो इस बार he is from IVR. I think वो ये उत्तराखंड में है ना.
Bareilly.
Bareilly.
So this guy was a director of IVR, retired and hired by Reliance. हमने कहा तुम क्या कर रहे हो बॉस? इंडियन वेटरनरी रिसर्च इंस्टीट्यूट. बोले उनका देखभाल रखते हैं. तो एक बार मैं गया तो मैं कहा तुम क्या कर रहे? बोले 200-250 करोड़ हमको मिल गए. मैं कहा किस लिए? तो बोले वी आर सेटिंग अप स्टेट ऑफ द आर्ट लेबोरेटरी. मैं कहा किस लिए? तो बोले ऑल द वे फ्रॉम GC mass to 2x2 GC to NMR and then even genome sequencing. So all these animals will go through the state of the art laboratories that you and I don't have. And even veterinary scientists from abroad.
And then how to increase that?
Huh? Both jokes apart. But imagine, they're not limited by powder. In fact, they're even thinking of selling powder. Like mangoes.
And we can't cut short Dr. Garg because it's very interesting and very useful. So I can only request him to explain.
Yeah, I'm done now. So this is, so we know about bio. So this is the summary slide. How we convert from where we are today. This is code red. All the refining industry are here today. We take in crude, we emit CO2, we produce fuels, less chemicals. To where we have to go in the future, and this will happen. In your lifetime, it will happen, not in my lifetime. I'll be dead and gone. So basically crude, biomass, waste plastic, renewable power, green hydrogen. These will be the inputs to the future refinery. And then what we produce is actually blue hydrogen, carbon utilization, syngas, all kinds of chemicals, including sustainable aviation fuel.
Why is not working on extending the age of people? So that you don't die by the time this happens.
Actually, from algae, you can produce some special antioxidants called astaxanthin. So that synthesis has also been done in Reliance using red algae. But somehow the management did not think that is a great business proposition.
Just one little question I thought I asked earlier, to interrupt you, when we working on algae in such a massive scale, what are the other byproducts of algae that are coming out?
Actually, mostly it is nutraceuticals. And to a large extent, now I think our demo unit is being put up to make 50 tons per day of proteins, which has been gone through FSSAI approval, as well as I think there is a body in US which approves it, including all the regulatory requirements. So 50 tons per day of protein is being produced, and actually there are many companies who actually produce meat-like products.
Synthetic lab-grown meat.
Yeah.
LGM. They call it.
Any other exotic chemicals?
Actually,
High value exotic chemicals.
yeah, but you have to look at the cost and the quantity, because Reliance doesn't believe in 1 kilo, 1 ton, 2 ton, 10 ton, 100 ton to 1,000 ton. They want millions of tons.
If you have the ultimate complete analysis, you will know what is there or what is not.
Correct. But in fact, one team came here also to see whether we can convert hydrothermal liquid, the bio-oil produced from HTL to produce jet fuel. I think some years ago somebody came here, right? Even that is being looked at. Actually, we have a large pilot plant to convert.
Ramesh Bojade.
He's no longer with us. But biomass converted to through hydrothermal liquefaction to bio-oil.
We thought it was promising, but he did not pursue.
Actually, economically viable nahi.
वायबिलिटी
बन सकती है सर.
मॉडल अलग है. क्या ना वो जो जेनेटिक जो कन्वर्जन वाला इशू है वो इसे परमिशन नहीं मिला है.
कौन सा? GMO नो.
वो नहीं मिलेगा.
वो तो इन्होंने बंद कर दिया ना, बायोडाइवर्सिटी. हाँ. नाइट्रोजन बंद कर दिया.
तो इसी के चक्कर में
has closed down GMO. But we do have genetically modified some strains, but they are still in the lab. We cannot put in the open raceway forms. That is actually a strain which is a natural stuff. But the beauty of the raceway ponds, which we have in Jamnagar, which I am not an expert in that area by any stretch of imagination, but what I learned is that this particular strain is so robust that there has no crash over the last 5 years, whether it is monsoon, whether it is winter, whether it is summer. So the raceway pond has not gone through a single crash, which is unique, because once you get into a crash, then you lose another 3 to 4 months before you get it revived again.
So maybe.
Sir, one question, sir. One of the talking point about the battery activity that you were talking about. Now, Clinton is investing very heavily to reduce the greenhouse emission of methane from the cow's stomach or animal's stomach.
Yeah.
Can you give some details regarding which direction it is going?
I have no idea on that.
If it is Bill Clinton, will it work?
Not Bill Clinton, Bill Gates.
Bill Gates. Okay. Gentlemen, my thanks to Dr. Garg, to Mr. Jain, to Mr. Venkatramana for these wonderful, absolutely wonderful presentations. I'm sure our colleagues in the IT would have benefited from that. Jalsa has given us a lot of thought for future directions. Mr. Venkatramana has done a wonderful analysis of challenges in operation and management of refineries of today and tomorrow under variable situations. And Dr. Garg, I cannot really even comment on how interesting and good that presentation was. So thank you, gentlemen. Thank you all. So what is next?
What money? So I think we have already had tea online, right? So आजकल तो online जमाना है.
Maybe we'll have a second round of tea.
Dr. Manisha, will you take over for the panel discussion? Please take over for the panel discussion.
That
अब पैनल में सब ज्वाइन
5 o'clock तक इनको 4 बजे
4 बजे का बोला था ना.
But they're there, down there. I can see them on there. So, yeah, we'll invite all to the panel discussion, but keeping the time situation in mind, we suggest that we try to wrap up the panel in 40 minutes.
We'll try to.
Yeah?
We'll try to do our best.
Yes.
It is your area of specialization, boss.
Well.
Yes.
It was not now.
Matthew is there.
Yeah.
Here we got to.
Dr. Abraham, Dr. Rajimathai. We have them all.
Hi, Matthew.
Hi,
How are you?
I'm fine.
You can see us all?
Yeah.
Good.
I don't see Dr. Mathai on.
Dr. Vijanta Ahuja from ICAT. Vijanta Ahuja.
I think you need to check them on the phone. I hope they did not go off.
I can.
Yeah, good afternoon, sir. So just a correction, I'm still not a doctor.
Yeah. Right.
Good afternoon.
Good afternoon. Okay, who else are we? One panelist is right here. Dr. Mathai is not here, but let us begin. And maybe somebody can call Dr. Mathai independently, but let us get started. Dr. Mathai, Mike?
They're appearing.
No, they're not.
Okay.
Let us begin.
So, ladies and gentlemen, I think as Dr. Anjan said, let us begin, and I'll just take a few seconds to make some comments to begin with. So my comments may be a little schoolboy, but I thought I'd like to mention that. Ultimately, we want good air quality. Sure. Now, the contributors to air quality are various things, so which we have all heard. But my grievance on that is that we do not have a very exact model or enough data to decide or to say how our air quality will be decided because of various kinds of emissions from various kinds of sectors and various kinds of sources. We tend to give more importance to automotive emissions, which may or may not be right. If we can eliminate all the automotive emissions one day, I do not think that air quality issues will end. So number one point that I would like to make is that, look, we want a viable, workable model on air quality prediction, for which we will need a large amount of data. And to do all that, let me talk only of the Indian context, let me not worry about the rest of the world. We need some agency in this country which can do that. We have various bodies, we have Ministry of Environment, we have National Green Tribunal, we have IIP, we have ARI, we have so many others. But I don't think that any one of us is doing a complete job on this subject. So my one suggestion is that we do something of that kind. Number one. Number two, we have seen from all the previous speakers how important carbon reduction is. We have all seen that a lot of work is being done on renewable fuels of all kinds. So second thing which I want to mention here, not that you do not know, each one of you knows this, but still I would like to say that. Look, the basic primary source of energy in the world, to my understanding or knowledge, are only two. One is the sun, and second is the nuclear. I do not know any third source of energy in the world. The sun we make use of through various pathways, petroleum, fossil fuels, biofuels, wind, and so on. Depending upon the resources which a country has, and depending on the skills and knowledge which a country has, we tend to choose a particular pathway for a particular amount of time. But the meeting point of all the pathways, in my opinion, has to be the sun or the nuclear system. Whether we have green hydrogen or we have EV, sun has to be made use of in an efficient and reliable manner. As I mentioned a few moments back, to my knowledge, what the data numbers that I have, 1% of the total incident solar energy in the world, if we can harness that, that will meet the entire world's entire energy demand for all sectors. And a few years back, Prime Minister Modi made a statement that, look, Ladakh alone can meet the entire energy requirements of India, not only electrical requirements, entire energy requirements, if we can possibly harness the sun that we have there. So this is all common knowledge. There's nothing very special that I am saying. And I think that whenever we talk about emissions or future fuels or future directions, this is what we have to keep in mind at all times. With these remarks, I'll request Dr. Matthew Abraham to please give us your views on this subject.
Thank you, Mr. Singhal, and welcome all the panelists there and also all the speakers. It has been a very knowledgeable presentation now. I would like to develop. Am I audible?
Yes, you are.
Okay. I would like to give the OEM perspective of the automotive industry on how we see the future. If you see the ambient emission, we are into BS6 now, and by next year we are going to the BS6 next stage, and subsequently in the years to come we are going to have BS7, or which is a very drastic change, because then all the emissions become fuel neutral, because all the emission limits will be common, irrespective of what fuel you use. So this is going to be the scenario where you are. Then over and above, you have the fuel economy norms, which were started in 2017, and we are into second stage, which is already started, which is having a tremendous pressure on the automotive industry, because as we all know that as the emission goes high, the fuel efficiency tends to deteriorate. So we have to make special arrangements to get the fuel efficiency back and to meet the challenge. Now, when we started making the fuel efficiency norms, it was almost in the 2015 or so. It all made in the assumptions that diesel going to be the major source of automotive vehicles, because that was the trend at that time. And as we all know that diesel is having a very high efficiency. So all the calculations were done because of that. Now suddenly all the things changed, and diesel is going in a decline. And then the gasoline is the option, but on a fuel efficiency norms point of view, it cannot be a candidate for the emission reduction. So now what you take in the US and Europe, what they followed is the hybrid route, which unfortunately or fortunately in India we are not looking into. But personally, I feel that that is one route which is going to be a balance between the electric vehicle and the fossil fuel vehicle, which is going to the plug-in hybrid, which is having a tremendous potential to meet both the worlds and to give the better fuel efficiency concept. Now, as I see the remaining parties, which all the speakers collected is from the renewable sources. What I see is that electric vehicles, unless it is reduced from the renewable sources on a well-to-wheel basis, how far it is going to be advantageous is something which we have to assess. And in that point of view, if you make an overall assessment on weight-to-wheel license analysis on the GHG emissions, then we have to see what are the candidates which are coming in. One is, of course, the electric vehicles, then the renewable fuels, the renewable fuels like biofuels, biogas, and bioethanol becoming a strong candidate for in the future dimension for as far as vehicles are concerned. So I don't want to dwell much on that. So taking the scenario of all the three drivers, that is the ambient emission reduction, the global warming reduction and the energy security, I feel that electric hybrid, plug-in hybrid, and electric vehicle, then bio-CNG and biofuel has to coexist, because I feel that no single fuel can replace the diesel or petrol. So all the four has to coexist, and we will be seeing a scenario in maybe in a couple of decades. All the four routes are going to coexist, and that will be giving a tremendous advantage. Make use of the local advantage of fuel availability and come to a sustainable position as far as the vehicle is concerned. So with these few words, I finish off. Thank you.
Thank you, Matthew. I would like to ask you a question on what you have said and what I have said. Are you aware of any model for air quality that shows the component of automotive emissions in urban areas or non-urban areas?
Can you repeat the question again?
You see, I'm trying to ask you if you are aware of a model that can predict air quality.
Yeah.
And in air quality, the component of automotive emissions.
Yes.
Under urban conditions and non-urban conditions.
See, there are environmental models which are available on the there are various models available which predicts the local environmental ambient air quality both on the urban and the rural side, where if you see one of earlier, I don't know whether you remember or not, towards my last tenure in IIP, we were working on this environmental modeling with the EPA, which you may be remembering.
Yes.
So this is some of the where Dr. Mitra had started at that time in the on the GHG emissions.
Yes.
So this is some of it. I mean, it was not pursued much. So this is what is something which you can pursue to take care of the emissions from the vehicle and what is its contribution to the ambient air quality. So there are models available which we can try out.
Thank you. Thank you.
Okay, sir, I would like to add to what Dr. Matthew has said. Currently in India, we all know that the ambient air quality standards, national ambient air quality standards, it includes 8 species of the things. And the most dominant part is particulate matter from that. So that is the anthropogenic source, the PM which is coming out. That is one of the species which is very dominant. And the AQI index, which you see in Dehradun, also in Clock Tower, will have a display of AQI of 50, 100, 200.
That's basically that.
Yeah. So that 50 is based on that model only. It comprises of all 8 species. It is calculated based on which is the dominant species, and it is indicating the particulate matter which is in the ambient air quality. That is indicating that this is the condition of the air quality.
I think the question was, can you apportion source? Can you apportion how much of the air quality impact is coming from, let's say, automobiles? That was single sub question.
Look, that's yes, exactly. The question actually what means is, take Delhi for example. So we are always talking about poor air quality in Delhi.
Yeah.
We are always blaming the automotive vehicles in Delhi. How much of that is right? How much of that is not right?
Sunil, sorry, Sunil, go for it first. Sorry, Devendra, go on.
No, please, but this study has been done in the country that is called source apportionment study.
Yes.
And one of the CSIR-IIP has been involved along with ICAT and other ministries. And they were the expertise in their domain to find out in the air sample that which particular species from which source it is dominating.
So how much of that work has been done? How much remains to be done?
So I'll update on that.
Yeah.
The current status is recently ARAI has done this source apportionment studies on the effect of your automotive emissions on the air quality.
So that study reveals that it is not much, it is 5 to 10%. They give that source apportionment. The automotive covers only 5 to 10%.
The automotive is 5 to 10%.
10%. Okay.
You trust the data?
I think I would like to state that about 8 years ago, there was an initiative by the Ministry of Environment in which about 8 agencies were involved in about 8 cities, 8 major cities. And they have done a similar exercise what the gentleman was telling. And at that point of time, it was 13% which has come out. 13% was the automotive contribution.
So this is in which town?
It was done in all the towns like Delhi, Bombay, Chennai, Bangalore, Hyderabad, Calcutta. So this was the various, there are 4 or 5 agencies involved. IIT Madras, Niri was not there. Kerry was there. Then IIT Bombay, then IIT Delhi, then CM was involved, and then the Ministry of Environment. So this was done about 8 years ago, where and they have put some stations in all these locations where the monitoring stations were put, and based on what he was telling that the particulate or some particular emission component was made as a reference point, and measuring that they determined what is the quality of air at that particular location. But the result was very, very, very interesting that because there is varied percentage of emission quality, I mean, source approach for the various cities. And it could be logically concluded with the geographical location of the place also, because Delhi, as you say, was giving the maximum contribution, whereas Bombay was giving the lowest contribution. And the conclusion was that because of this air dissipation, in which Bombay is more towards sea, so there is more dissipation. That's why you could see less. So it was piloted by CPCB actually.
Okay. Is this an ongoing project or this was one-time project?
No, it was one-time project. Was completed. ARI was also involved. Yeah, ARI was also involved.
ARI data was there, 10 to 15%. That was the data I think 2020 reports.
Well, anyway, I would like to suggest that there should be a ongoing model, not that it should be closed at any point of time, because the data will keep changing and our knowledge will keep changing and our model will keep changing and things will...
Points well taken, sir. Because this National Clean Air Program, under this program, now they are going in a different cities, tier 2 cities also. So there are certain plans, and in Dehradun also, we are having kind of consortium which we are planning to have this kind of studies. So this is correctly said, funded by CPCB, but the whole program is governed by NCAP, National Clean Air Program.
Okay.
Thank you.
Thank you.
When I was EDCST,
Yes, sir.
so I got a report on which command was supposed to be given. The World Bank, World Bank published a report, and there was discussion North Pole. So I was also there, and India report there was a discussion going on. In 2019 it happened. Okay, so that was a draft report, but they must have published now that the final report should be available. City-wise analysis has been done there, including Delhi and all the major city what Dr. Matthew was talking, and the contribution of each factor, including the climatic condition and the neighboring states.
Yes, everything.
Everything. So this vehicle pollution was not a considerable factor there, less than 20. It is what I could get there in that road, particularly in Delhi.
So Delhi is the stubble burning is we blame all the time.
Yes.
Well, is that right or is that not right?
It was right. Because that means data were of 2018 and 17-18 data.
Yeah,
of course, now Delhi is much cleaner.
19, that data was published in 2019.
19.
And they said because of DG sets, they are blaming basically DG sets in Delhi. So the data was produced and they said the percentage of this contribution from DG sets and other automotive side, it is 5 to 10%. I don't remember exactly data, but it is 8 to 10%. It's very minimum. But it is very questionable because
the dynamics keep on changing from city to city?
I think they should continue.
Just for information sharing, Matthew will perhaps know. Matthew, we did the project with CSIR-IIP on air pollution. Do you remember that?
Yeah.
Ah,
Actually, as a second phase only, Dr. Mitra has started at that time.
Okay. Under that CSIR-IIP project that did many years back, you people were not there at that time. We made one recommendation to synchronize the traffic lights in Delhi, so that the vehicle movement is continuous, the idling time is less. Our suggestion was accepted. This was implemented first in Delhi, perhaps in other cities also now. I don't know.
Yeah, that's why in Delhi, while driving the car, one green signal gets time green. Yes.
At that time, our model was for driving at 30 kilometers per hour, you will get all green lights. Now the numbers can change.
Yeah.
Numbers can
Do you
change.
remember that, sir? You are driving by 40 kilometers per hour, you get, if you are having green, then.
Yeah, I experienced, myself experienced. Every time
Yeah. That is actually done by planning.
Yes. Actually, once upon a time, as you will remember, we were very keen to do work of their kind in IIP. We looked at the EPA model, we looked at the California model, we looked at many other air quality models, but we could not take that work far in IIP.
Yeah. We are presented actually a project proposal to the Petroleum Ministry at that time.
Yes, the CHT, as a matter of fact.
Yeah, CHT.
It didn't cut much ice at that time. Any other questions, comments from any colleague to Matthew or to anybody else?
Only the one remark I can make that the director was saying regarding the CNG story, Dr. Matthew Graham led the issue of development of emission standard for portable genset first time in the country.
Yes.
He was that particular technique.
Matthew, you recall that?
Yeah.
You did on gensets?
Yeah. First genset standards. That was in 1996.
Longest back, yes.
Now we have gone CPCP 4 standards, sir, now.
Yeah.
Will you like to add anything to this information that we are discussing? Anything at all? Devendra, Sunil? Any suggestions or ideas from you?
Only one thing that the air quality not only is PM 2.5 emissions or particle matter we're talking, the noise pollution is also coming in a big way. And we have done some studies with collaboration with some other organizations, and there's a lot of talk about net zero carbon emissions, scope 1, scope 3. Nobody has linked with the finance also, because there is a regulation from the SEBI that it's clearly mandated that every organization will submit their business sustainability report. It only not depends upon scope 1, scope 3 emission. You want what disposal you are doing, what water consumption doing, what are your business practice in terms of human resource handling. The picture is much bigger than that.
Yes.
They have the Western world has connected everything with the finance, because investors need to know with this sustainability and net zero, how is investment is going to be affected in future. So picture is much larger than that.
No, you are very right in saying that picture is much larger. How much larger, we have not discussed that here. But just to remind some of you, and Matthew will know this, when we did this work with the CSIR-IIP on air quality, we had also collaborated with KEM Hospital in Bombay. Ultimately, the air quality affects our health. Now, people like us do not know what parameters are involved in that. So, some KEM doctors were trying to help us make sense out of the data. Again, I don't remember what came out of that. So again, I come back to my basic suggestion that when we talk of a air quality model, we have to first understand what is that air quality going to do. How is it going to harm us? Why do we want air quality of a particular number? So the total composite picture is too large. And in my opinion, I don't know enough of what is going on these days. I can only talk of 20 years back. I don't know now. But we need a body which can take a holistic picture on this subject. And based upon that data, the government of India should act on numbers. What emission standards, what everything else, what fuel quality. There are data-based decisions on air quality or other things.
Yeah, you always said this thing that we should have a EPA kind of body here in the country also.
Yes.
Similar capacity.
Yes. Yes.
2020.
Yes.
Yeah, Dr. Ibrahim.
We all have emotions on air quality.
I think just to add to what there are some studies done by IIT Madras where you have analyzed the carcinogens from the diesel samples. So
Yes,
the benzopyrene and benzene-based variants, which are carcinogens. So there are some studies available in the from India itself. So probably you can go through that, and it's worth exploring that.
Matthew, after you had left IIP, we had done some work with the NIO Goa on the particulate unburnt hydrocarbons adsorbed on carbon molecules out of diesel exhaust. But we did not have the equipment in IIP at that time. So they could do some PPB or better analysis at NIO Goa. We had sent some samples there once upon a time. So carcinogens are very important. Not just particulate numbers or in air quality.
So we recently did this, I just add to this, on some, what we did is, we took the diesel and biofuel, one of the biofuel, maybe biodiesel things. We analyzed the particulate matter, not only gravimetric, chemical analysis was done in IEP itself. And we found that as per EPA rule, 16 species has to be found of that. And there two categories are class A, carcinogens, and that is benzopyrene and other things. So we found those things in diesel in some limit, but it is almost negligible in biofuel. So that was the added. There is a database and it's published work.
There is some science behind that, of course.
Yes and no. Because when we are talking of benzopyrene or some other carcinogens, we are not talking about PPB level, we are talking about PPT level. So you need equipment which can measure at that level.
Yes.
Which I don't think anybody
not at this time
around has, or even to my knowledge. Anyway.
Sir, we should move on. We have 10 more minutes. Vijayanta, who just
the other people waiting.
Yeah, I can't. Vijayanta is missing.
So Matthew, thank you for your comments.
Thank you.
Appreciate that. Then let's hear other people also.
Yeah.
Thank you.
Vijayanta, madam is here. Madam Vijayanta, please.
Dr. Ujala, welcome to the gathering here.
You need to unmute yourself. Please unmute yourself. You're on mute. Now we are all good.
Thank you so much, sir, for inviting me, and congratulations to all the leaders here. And my privilege and pride being here to learn from so many experts, and there were many myths which I also had, because I'm not, the age-old member right now. I'm just beginning in this area. So I would be representing ICAT, and I'm working in ICAT in the areas of regulation and supporting the government in their policies and the other regulations, being a small part of the whole group. So, sir, I think members have given a lot of insights, but I will just, wrap up a few sentences like, yes, we are approaching in the right direction, wherein we are talking about emissions. It has become, the word in everyone's vocabulary right now. So reducing the dependency on the import oil could be one of the things which we are targeting as in the transportation sector. And the manufacturers are meeting those targets, because we have some targets set in the areas like the passenger vehicle, 3.5 tons, we have the CAFE targets, and we are extending those targets to the HCV, LCVs, and maybe we'll capture the targets for two-wheelers and three-wheelers. The governance has become robust today, and improved emission cycles, and the real world CO2, which we started implementing from this year onwards, and the in-service conformity definitely would give us the right directions to get into the vision where we want to reach. But definitely what the members also pointed out, monitoring and recording the data not on the periodic basis but a continuous basis would also give us insights, because the period differs. Like in 2018 when we did the Delhi study. There were IIT Kanpur and other members who gave the study results. Those results were time bound because at that time, pollution was rising. But then after COVID, or what happened during the COVID periods? Now, what is the change of the customer preferences, the different types of vehicles coming into the on the roads? But we also forget the off-road vehicles, the off-road emissions which are also being generated from the gensets which are mounted on the trucks, the CVs or the constructions which go on. So those equipments never come into the picture when we are talking about the pollutions. So we should also target those, the off-road vehicles wherever the constructions and other things are going on. So that can give us that when the areas are being developed. So what is the impact not only of the on-road vehicles, but also from the construction, the infrastructure things which are happening. Definitely, it is an intermix of all the sectors which come into that picture when we are talking about the air pollutions. The government has taken a lot of steps. Like I worked with government on the FAME 2, the subsidy schemes, bringing the EVs into picture, the CAFE targets, the RD. So these things are taking a shape. But then the results which we could see, maybe it will take time. But the impact is because of the regulations, because of the change in preferences, because of the EVs would be very difficult to comprehend immediately. So I think the large portion of emission savings potential is low carbon technology and the actions and the behaviors of each and every one of us. Together we can always create a difference. And to conclude from my side, the decisive policy of the government and the suggestions from the think tanks like the experts would always bring about the change in the whole air pollution outlook. So thank you. That's from my side. I cannot hear, sir.
Yeah, now please. Please ask her now.
Can you hear us now? Can you hear me?
Yes, sir. Yes, sir. Yes,
Thank you. I would like to understand from you at ICAT, do you have any projects other than measuring and testing on this subject?
So currently, we have started now. We have backed some of the projects with Terry right now. And definitely we were not into the projects earlier. But since now, like I think 2022 onwards, we have started, working on the projects wherein we can, contribute and our equipments and expertise can be used to certain extent. And we can also develop some kind of an expert.
Thank you. Thank you very much.
So I would like to add one thing.
Thank you, sir.
We have just initiated one collaborative project with ICAT, and we have proposed it to be its own energy complex use. So we have proposed that, and there is a presentation meeting on 27th.
Very good.
So we are just collaborating with each other to harness their capabilities to have a synergy between the two organizations. Like we are lacking some of the testing facilities they are having. So we are just synergizing those things in getting a good.
Thank you. So I would like to make a recommendation to Anjan from IIP. If you can make the suggestion to the appropriate bodies, if we can have a collaborative model from all concerned, which is not a one-time project, but an all-time project, which continuously collects data, puts it into the model, predicts, makes recommendations to the government on air quality and things of that kind, like EPA.
Yes, I think that makes Devendra is smiling because it's kind of working those lines. Yeah.
What you are saying, sir,
that's kind of where we are going.
This activity now. So we are taking decisions on database, and that's why a new area that climate change.
Yeah. What we have to do though is, just like we collect seismological data now across the country, we have to collect the real-time AQI data in a meaningful manner, not just based on static inputs, but based on cause-effect apportionment at every location. Only then will big data analytics become viable. You have to couple it with our supercomputing power at 4PI.
Right. Why I keep repeating my comment unnecessarily is because, do you know the size of EPA? How many people work there? Are you aware?
Oh, I don't. I have
Yes. How many thousand people work on just on this subject?
Right.
So what I'm trying to say is that look, what I'm suggesting is not a simple task or easy task. It's a very comprehensive, very large, very expensive task, which only governments can do. Nobody not one organization like IIP or anybody else cannot do.
Yes, that's why we need to at least take all the testing agencies to start with, like ARI, ICAT.
No, not testing. I mean, I'm
data collection.
I'm not on testing. I'm on a model preparation in which the inputs can be defined. Testing, many people can do. I'm not on that.
We'll discuss this offline, Devendra, because this is one of those ideal areas where you can look at citizen science and data science, bring it to power all the universities across the country.
Yes.
Agencies. You have to define the model and then have people come in for the inputs. So we can take this offline, but it's very, very good idea.
Good idea.
In fact, the NCAP program says that around 5 or something, basic mapping of these things, start with mapping of that and subsequently.
No, one of the issues to me, like I was actually not in agreement with the NCAP program for two reasons. One is it maps cities with the operating assumption that air quality is local. It is not, right? If you look at the overall atmospheric science, the data, and the way pollution in city affects city B, you only have to see Punjab and Delhi to understand that. So I think we need a much more complex, much more encompassing model. But somewhere it has started. We should. When I say we, I don't mean IIP. I mean all the learned people on this call and off who have inputs into air quality need to work as a single consortium with a very well understood, well defined data set, and then turn the country into a set of collection agents.
Yes. Yes.
Yeah, Professor Day, very atmospheric science. He has done this study, what sir is emphasizing. What he did, he took a satellite photos throughout the year and he tried to find what is the reason why Uttarakhand, especially this foothills of Himalayas, and he showed pictorially, taking the data, how much PM is dominant during the winter season and how it goes away with the coming of summers or rainy seasons. It goes away like anything. It's completely green.
Yeah.
And when it comes to winters, October to November, it's completely red. And it's not only this, what I just said, it is not only Uttarakhand or Dehradun. The maximum pollution which is coming in India, here is the connecting cities, Haryana, Punjab, and other. And these particularly get tracked with the Himalayas. And he has showed it scientifically. Throughout the year, he took the data, huge data set.
Yeah.
So I have
No, I've seen so Professor Day's work. It's kind of localized. I think what we're trying to see is whether you can take it national, because whether it's terrain, whether it's wind currents, everything influences AQI. So we are tending to oversimplify models in India, and I think at some point we need to get beyond that.
He took the whole India's maps. I'm just emphasizing Uttarakhand.
Yeah.
Whole India, how the PM is changing or the whole AQI is changing throughout the year. Fantastic data. I was just in touch with him. So
World Bank report also, heat map is created.
Yeah, let's pursue that, but let's try to make it actionable. Having the data should also be able to get us to understanding where are the point sources of the problem. Where is the greenhouse gas effect getting maximized because of geospatial features? To be able to use that for actionable outcomes is critical to the success of this. Otherwise, we'll be doing data till there's nobody on the planet, right?
Is Dr. Mathai in line?
No, he's not going to be joining. No. So we should wrap up, sir. We're at 5:40.
Matthew and Dr. Ahuja, our thanks to both of you.
Thank you.
Discussion that was very interesting. And I hope, as Dr. Ray says, something comes out of this discussion. IIP can propose the program.
It's an excellent idea. What you need a national data on this ambient air quality.
Yes.
That is what we have to try.
Yeah, all related parameters, all like EPA.
Right.
Health effects and what effects, all the things. Thank you, Matthew.
Thank you.
And my thanks to all the colleagues who took part in the discussion and are here for this purpose. And my thanks to Dr. Ray for organizing this wonderful gathering. Very, very impressive, actually. And I hope we have more such gatherings.
Thank you.
Thank you.
Back to you, Dr. Manisha. Last leg of this alumni meet.
Yeah, thank you, sir, for conducting the session. I would like to thank all our eminent speakers and panelists for guiding us. And this surely will be helpful for us in designing the roadmap and also help us in strategizing our research plan for contributing India's net zero goal. Now moving on, we would be happy to open the forum for our alumni. Please share the memories. We have one
Here
as well.
he stepped out.
He'll be just
Stepped out. Can we take the online ones?
yeah, we can. We would be happy if somebody from our alumni would kindly share their memories or their experience with us.
Who do we have online? We have Raghavendra.
So we have Dr. Amar Holder.
Dr. Golder is back.
So,
Doctor, I didn't complete my PhD. Beg your pardon.
So I would like you to kindly share your experiences with us. It's open forum now for all of our alumni.
I think P.K. Gupta was our student perhaps.
Yes.
With the Dr. Anshu, lab.
Yeah. Let us start here. Let us start in the room.
Yeah.
It's a pleasure that I am invited to the Alumni Association Week and especially requesting Dr. Ajay Gupta to present here personally so that I can share my experience. I had a very brief stint here in IIT for about less than 3 years. I came all the way from Delhi when Delhi was its at its peak in 1991, December, with very heavy pollutions. And it was an opportunity because I was already doing, having a PhD program in Delhi University, but came to Dehradun to meet on the invitation of Dr. Prashanada, pursue the PhD program here in IIT. And on the first meeting, he told that please be our guest and pursue your career from IIT Dehradun. And I accepted that offer and started my career from here from December 1991. But while pursuing my career, because I'm the elder son, I'm the elder son of the family, my parents' father was critically ill, and it required my personal intervention to present him the home to look after because I had 2 siblings also. And there was no other option but to abandon my study in 1994 February. I went back and immediately I lacked a job in Castrol India Limited. That time it was one of the giant lubricant industry. And from there I started my career as a professional. I worked in Castrol India Limited. Then after that I worked in Valvoline Cummins Limited. I worked in Confederation Indian Industry. And then because the career was stagnating and I thought that probably it will give me a feeling by pursuing my MBA. And I got an opportunity to pursue my MBA from Indian Institute of Foreign Trade, which is being institute under Mr. Thomas. And I completed my MBA in International Business in 2004. And from there, then I started because while pursuing my career, I was in tremendous place to do my justice for my both career as well as family as well as my study. And I was transferred by Valvoline to Calcutta to look after the key accounts like Tata Cummins. In between, we had done a lot of job with Tata Cummins when Valvoline merged with Cummins India Limited to become the Valvoline Cummins Limited. And they had a very super oil, power slit and power soaping, which is the OEM oil for the whole Tata fleets. And we had the engine testing studies for the ECB building, which came then in 1998, 1999 to 2000. And I did a lot of work on that. And because of that technical, I was transferred to Calcutta. And I had a stint of around 6 months to complete my MBA. So without any thinking, and I left the job and completed my MBA. And within 2 months, I left up one foreign company who appointed me as the country agent to look after their more interested. And from there, this I'm now agent for 4 companies worldwide and sourcing the raw materials, particularly molecular chemicals, corrosion inhibitors, some lubricant additives, and it's a win-win situation in which I get the remuneration from both foreign companies as well as the Indian supplier. So
Nice. Wonderful. Just curious, so you were here 91 to 94?
3 years.
With whose lab? Who's the lab?
I'm a doctor.
After that, Dr. Muralidhar. Because my niece was also here around the same time. She also had to leave for family reasons. So maybe overlap with her. I think she was with Dr. Rawat. Joyita Roy, do you remember her?
Yeah.
So she also left. Her father was very ill. Now she has done something very similar to what you did. You're in touch with her still?
No, I'm not in touch with them.
Very interesting.
Very nice.
All right. So,
I'd like to mention a thing or two.
Yes, sir.
Look, I would be failing my duty if I do not put on record a contribution by all the directors from day one. Dr. M. Krishna was the first director. Before that year, Dr. Whitaker, who was the scientist in charge of the laboratory, was not the director. Dr. Whitaker, Dr. Krishna was the first director. 1965, this building was not there, as I said in the morning. And he used to go to all the labs and see. So I was in the Angus laboratory. We had a secretariat in the first room. And since all the buildings are new, our building used to leak. There was some puddles of water on the ground. And then one day he came in the room and he saw that there are puddles about the ground. So Satpal was the PA to the division. So Satpal, you have a duster? Yes, sir, I have a duster. He doesn't know why does Dr. Krishna want the duster. So Dr. Krishna takes a duster from him and starts sweeping the floor. Now, once he starts doing that, everybody says, sir, hum kar denge. Tumne karna hota to pehle kar diyo. So we had directors like that. Then, of course, we had Dr. Gulati, we had Dr. Krishna, we had Dr. Prasad Rao, we had Dr. Garg, and who else? Michelle? No. Forget me.
Dr. Rajavan Krishna, you mentioned him.
So each one in his own way. R. Krishna, I mentioned him. Each one in his own way has done wonderful work for the institute. Wonderful work.
I may say, sir, that IIP is a very rare institute in CSIR because the average tenure, the mathematical average tenure of a director here is almost 8 years.
Yes.
So continuity has been very good in IIP.
Very nice, very nice.
This is very important because in a lot of institutes, we've had directors change after 2 years, 3 years, and frequently. But here, there have been relatively long stints of continuity.
I think M.G. Krishna ji was for 9 years or 8 years?
He left in 1970.
I think.
2 or 3.
For
on the request of the Prime Minister personally.
So 9 years here. Then after that, you have Dr. Gulati also. For long, very long, 11, 12 years.
11 and a half.
Yeah. Only Rajavan Krishna was relatively short. Only 2.5.
Is that for 6 years?
No, he was
2.5.
About 2 years.
I think then Dr. Prasad Rao was 8 and a half.
He was 4 long.
And you're between your two stints almost 6 years, I think.
6 plus.
6 plus. No, it's that has been one of the unique features of IIT, the sense of continuity. Let us hear from our colleagues on the call. Mr. P.T.R. Gupta. Yeah, is he there?
Anybody at all?
Is he there? Please SMS me. I'm in a meeting. Please SMS me. Send me an SMS. I'm in a meeting. Send me an SMS. Thank you. Anybody else who is online who would like to? Raghavendra Singh, Rachit Jain.
Rachit, are you there? Rachit Jain.
Anybody else?
Need to unmute him, I guess, on here.
No, we can't unmute. He has to unmute himself.
Unmute him, but or not.
He can only unmute himself. Who else?
Bottom may we can see if some.
No, that is all. That is all. No. Let's see who else is there. Ravindra Singh, Rachit Jain, PTR Gupta. Three names that I think are.
No, not of, Sajid, I remember the Bangladesh guy was there.
Matthew is there, right? Matthew is an alumni.
He is, of course, that's why he was on the panel.
In the panel.
You don't see anybody else.
Will you find somebody? Let me tell you very interesting experience of IIP.
Okay, there.
Can we?
Just now.
As a panel. I have spoken as a panel.
Right. So we have, who else is here? Nobody else? No.
Let me tell you a very, very quick one. When we and IFP, because the IFP had set up, we are on the IFP model, Institute for Civil Petrol, and we are exactly on that model. And all the four heads of divisions, five were French people, four were French people, except engineering services. So my head of division was Mr. Thierry. Now, in those days, let alone cars, we did not even have scooters. And only two people in IIP had cars. There were two deputy directors and Dr. Krishna had small cars. And when these French people came, they had those large, big cars which they imported. And they had frequent meetings in Delhi and they used to go there. Now, Thierry was very fond of driving very fast. And so sometimes once in a month, twice in a month, we had some evening get-togethers. So Dr. Krishna asked Thierry, I believe you drive very fast to Delhi. You reach Delhi in 3 hours in those days, on those roads, in those roads. So I happened to be standing there. I was very junior. I was a research fellow, not even a scientist. He said, yes, Dr. Krishna, you see, Indian roads are very bad. The less time you are on them, the better.
Dr. Abraham, let us hear at least an anecdote from you, not a technical story, but one of your experience anecdotes.
Well, I think I've been there till 2000. After that, I joined, of course, the automotive industry. My recollection is that we had an excellent family because when I was there, that was a peak time when engine slab was there. We were about 23 scientists at that point of time.
I just have to be alone.
23 scientists at that point of time.
Yes.
And that was one of the prime period when, as far as engine slab is concerned, where we had a lot of interaction. And one thing I think Mr. Singhal forgot to mention is about the UNDP program and the methanol programs.
Yes,
which we did were really futuristic at that point of time. Maybe in the what I'm talking about, early 80s and the mid 80s.
76.
So we had a lot of sort of enhancement of our technical capability, which happened at that point of time.
Yes,
so
yes.
These are the two programs which are very much landmark programs as far as the engine slab is concerned. And we all could learn because a lot of experts used to come to us and a lot of people used to go out and do short and long-term assignments. It enhanced the capability of that time.
Yes, absolutely.
Yeah. And 2-3 things which I want to mention here, that we were the first to set up a emission analyzer in the country.
Yes, yes.
We were the first to put a engine digital analyzer in the country. And even my PhD I did with that digital analyzer, which analyzes the combustion parameters inside the engine.
High-speed camera. High-speed camera.
Very much high-speed camera. Then the combustion bomb facility, which we did with one of the top experts in the IFP, Dr. D'Souza.
Dr. D'Souza, yes.
So these are all landmarks which we cannot forget, and which has been sort of a milestone in the history of the institute.
The chassis dynamometers also, the two chassis dynamometers, the first in the country.
Yeah, right.
So much more, Matthew, so much more.
Yeah, so much more. I just pointed out some of the key things.
Thank you. Anyone online who would like to say this is the last chance? We do see some of our alumni out there, but they are all on mute. We have two out. We already lost Raghavendra. PTR Gupta, Richard Jain. No. Then back to Dr. Manisha. Please let us wrap up.
Thank you, sir. To express our gratitude to our chair and to our invited speaker, I would like to request Director CSIR-IIP, Dr. Anjan Ray, to kindly present the mementos to our eminent guests. So first, I would like to request Mr. Sudeep Simplesworth, kindly please
Actually, again, I didn't do much. Everybody conducted himself here.
That is what the conductors and the orchestra say, and the captain of the team says in a match, and all of that. But eventually, when the news headlines come, you only hear about the conductor and the captain.
Well. That's been very kind. Thank you. Thank you.
Thank you. Good, sir. Again, please.
All right. बिना संकोच का अपना घर समझ के हमारे घर है भाई.
To request Venkataraman sir, kindly receive.
The pleasure that you could come after in person. Yeah. Thank you.
Monday morning.
I'd like to request Shri KK Jainji.
While some of our brothers, we might also be angry.
No, that's बिल्कुल कहने की कोशिश. Thank you.
On to the end of the alumni meet. Now I would like to call upon Dr. Ajay Kumar Gupta, convener of Alumni Meet OWOL program, CSIR-IIP, for his vote of thanks.
Good evening, everyone. It is my privilege to propose a vote of thanks. At the outset, I, on behalf of CSIR-IIP, would like to express my sincere thanks to the eminent speakers for their thought-provoking talks. Mr. U. Venkataramana on challenges and opportunities in oil and gas industry, Dr. Amoga on future refinery configuration, and Mr. KK Jain on future R&D direction for attaining clean and sustainable energy. Thank you, sir. I wish to express my thanks to all the panelists, Dr. Matthew Abram and Mrs. Vijenta Ahuja for their valuable inputs for curbing automotive emissions and achieving net zero, and of course, improving air quality index. And also to Mr. Sudhi Singhal sir for chairing the session and keeping things under control and on time. Our sincere thanks to Dr. Ram Vishwakarma ji for gracing the occasion virtually. And we are also most grateful to all who attended the event online or on-site and helped to make it such a big success. Many thanks to Dr. Amar Golda and Dr. Abraham for their memories with the CSIR-IIP. I would like to thank Dr. Anjan Ray, Director CSIR-IIP, for his guidance in conducting this event. Our sincere thanks for covering this event. Finally, thanks to all who are directly or indirectly involved in conducting this event. Thank you all and have a great evening.
Thank you.
Thank you.